There we go. Thank you so much. Right, welcome back, everybody. Let Hillary in. Welcome back, everybody. This is day 2 of our introduction to R and R Studio. Really hope everybody found something valuable yesterday. Started to get a little hint as to how you can apply some of these things to the work that you've been doing in any other kind of coding or in any kind of analytical package. Yesterday, we covered a lot of ground. Okay, so I'll share my screen to show you what we covered. So yesterday we went over a little introduction to what R is, the language, and then the IDE, the integrated development environment, or the program that sits on top of that we were using called R Studio, made by the company called Deposit. We had a little tour around that. I introduced you to the concept of R projects, which is a nice way of working with your files so that you can lift and shift an entire project to somebody else, and all of the file paths in it will just work because it's all relative to the root of the project. We even made a little tiny Quarto document, which Quarto is a way that R can be used to make really nice, really easy to create combinations of text plus code plus the output of code. And this can be a really, really powerful thing in your working lives to use Quarto reporting. We then moved on to import some data. Little bit of a struggle for some people, but that's a really important part. So we took some time for that, and that's totally legitimate. So we imported a CSV using the import wizard, CSV being that most basic, essentially, form of text file. We did that with a nice clean CSV that had what we were expecting, and then we imported a slightly more realistic, messy CSV, where we needed to do a few little bits of cleaning before it would be in that tidy data format, that nice rectangular format of one category, if you like, per column and one observation per row, which is really important for what we'll build on today as well. And then we saw an example of going to the web and taking a table from there. A lot of the data that you guys will use will be on the website, be it from ONS or the government or whatever it is. Being able to just drag that straight into R, not having to download it and save it somewhere first, is a really powerful thing. And then we moved on to talking a bit about packages. And it's a concept that sometimes takes a couple of times for you to get your head around, but once you have, you'll be flying. So packages are the way that we extend the functionality of base R. We download and install them ourselves, hopefully, because your IT department should be fine with that. From CRAN usually, which remembers that Comprehensive R Archive Network or something. And CRAN is the place where most of the really, really well-used, well-supported, well-maintained packages live. And your version of R Studio, when you say install a package, will go there by default. But we can get development versions of those packages from GitHub. You can create your own packages if you get to that point. And we can install them straight from GitHub too. One of the main packages is the tidyverse. That was that great big package containing packages one of them we used yesterday to wrangle some data, the dplyr package. Plier like the tool. I don't know if you do that with the plier, actually. I can't remember what you do with the plier, but dplyr is there to wrangle your data, get it into a nice format that is usable, that can be picked up and worked with straight away by the things that we'll look at today. And we did a few different bits and bobs with dplyr. I also showed you how to pipe commands, which is where we link them together, like that recipe to peel a potato and mash it. We've got one step, then the next step, then the next step, and we can create any length of these things using the verbs that dplyr gives us, those functions that dplyr gives us. With just a few words, we can start to have an instinct about how we would want to use dplyr to manipulate the data into the shape that we would like it. So I just want to flag on, because in this course, so I might end up rejigging some of the order of this course, because I think Quarto comes up a little bit earlier than it should. Yesterday, we made a Quarto report. It was really helpful, okay? But it might have seemed like a little bit like, whoa, we've jumped ahead a little bit here for some of you. I'm showing you this screen now because NHS-R community, our lovely, friendly, cuddly community, and we also have some introduction to Quarto training. Now, we don't tend to do this training as regularly as these introductions and intermediate ones are, but just like the slides and the code that made the slides and all the rest of it that you've got for this course, we have the equivalent for Quarto. So if you saw the Quarto element yesterday and thought, oh, do you know, that actually could be something really helpful, I will direct you to this URL here, which hopefully Kaylee can pop in the chat. And this is, again, a little step-by-step course of how to start building and working on those Quarto skills so that you can have a single Quarto file which will create you any number of really well set out, really beautiful, but also reproducible analytical pipeline Quarto reports. Okay, so that you can do in your own time. If you're dead interested in that, drop us a message at the community. We might end up producing this kind of course again to actually host this course and take people through it. But what I'm saying is the materials are all there, freely available. Go and have a look. There's slides like there are for these courses, and you can see what you can get out of that. Right. So coming back to today then, we're going to move on and do a little bit more dplyr. If you remember, dplyr is the function that we used from within the tidyverse package. And dplyr itself is a package, so you can install it without tidyverse if you want to. And it gives us a lot of different ways of restructuring our data, for example. Kaylee, you have your hand up.
Yeah, I've just received a question whether Quarto is the same as R Markdown.
So Quarto is like the new breed of R Markdown. R Markdown's been around for, I don't know, 20 years or something. And it's brilliant. It's great. It's done the job for everyone forever. Posit, the company, has produced Quarto now, which is newer. It will eventually replace R Markdown, but R Markdown isn't going anywhere anytime soon. Quarto can do a few more things a little bit better than R Markdown can, including more natively supporting lots of different coding languages, which might be of no use to you right now. If you have an R Markdown file that you've created, so that one with a .rmd on the end, that will just work if you use Quarto to render it as well. So any R Markdown should just be plug and play to use with Quarto, but not necessarily back the way. So if you start off creating a Quarto document, you won't necessarily be able to put it back into an R Markdown because they've developed it a little bit further. So using Quarto, if you've used R Markdown before, should feel very, very familiar to you. So yeah, if you start with one or the other, doesn't really matter, to be honest. They're both going to be around for a long time, but being able to produce reports using code is really powerful. And if you are the person in your office that knows how to do that, you'll be very popular as well. So brace yourself for that. Okay, let's start with our slides today. More dplyr. So we've got some more useful functions, some examples of their capabilities for manipulating data. And remember, we said yesterday that you'll all know this probably if you're analysts already, that getting your data into a sensible, clean, usable format takes a lot of time and effort. This all makes it a lot more easy. So select is another one of these verbs, if you like, these functions that dplyr provides to you. So yesterday we looked at, what did we look at yesterday? We used filter to select a subset of rows to do something with. We used mutate, and that's a really important one for making new columns. We used summarize, and we used arrange, okay? Today we're going to look at select. So similar to filter, filter works row-wise. If you say filter and you give it some kind of a argument, say yesterday we said, just give me the rows that have a particular date. You can think of select being transposed. Select is about columns, okay? So select will allow you to select only the columns that you feed it. So have a look at this here. Remember, our beds data was the data set we finished using yesterday, finished the day using. Here we're taking the beds data and we're saying, take this data, then select, and in these, and again, this didn't have to be on two different lines here, we could have just carried on. Select these two columns, one was called org code and one was called org name. And if we ran this, we would produce this table. And again, quick reminder, a table is just a type of table, essentially. It's a good way of using tables in R, but don't worry too much about that. And we can see here that this table has brought back just the org code and just the org name from that data set. In fact, let's go into our R data project like we set up yesterday so you can see this in action. Hopefully you've all managed to get back into Posit Cloud if you were using that yesterday, or back into where you were working. So I just opened that and see it's sitting here as if this is exactly where we were yesterday. I didn't ask it to go to this, but it remembers, which is quite handy. Quick reminder, this is the files that we are creating. If you like, this is the script. I've called this one test.r. I'll close these down to show you them. Down here is the immediate outputs that we get. So this is the console where if you wanted to just type in quick and dirty sums and press enter, you would get the answer immediately. But here, we are not getting an answer if we do that, if we press enter, because it's waiting for us to run it, okay? And the way we run bits of our code is either we can highlight them and press run, or with our cursor flashing somewhere in that line, you can also hold down Control and press enter, and then the console knows that you've said, right, give me the answer now, please. Eventually, we will end up with big long scripts of code, and we'll just press run on the entire thing, and then everything will happen sequentially and all at once. Across here, we've got our environment where we have kept the things that we created, okay, so objects that we created as such. We've got 3 of them here. The beds data is the data that we fed into it that we'll talk about. So this is the 4,558 rows or observations of 5 different variables. And we can get a bit of a summary of what's in there by clicking this little down arrow beside it and see the different types of things. If you want to actually have a look at this data, we can either click the name or we could click this little table over here. So here's our beds data. We've got these 5 columns. We have an org code and an org name. So you saw that we were just going to select the org code and the org name. I'll copy this and show you what we do here. Get rid of all this stuff. So I'm going to Control Enter on this, and down in my console, you can see that it's brought back that table with only those columns that we asked for. Nice and simple. So you'll use select a lot. You can use select by giving it the names of the columns or the positions of the columns, okay, and or a range even from the colon to. So let's do that. How many columns does this have? It's got 5. Yeah, it's got 5 variables in this. So if I said select me 2, 4, what do you think that would do? Any guesses?
2 and 4.
Yeah, it's selecting the 2nd and the 4th column, which we can persuade ourselves of. So we've got the org code, that's the 2nd column, 1, 2, 3, and then the beds AV column is the 4th column. And as it said in the notes, if we put a colon, what that's saying is take from the first number all the way to the 2nd number. So take the select, bringing back the columns from the 2nd to the 4th, inclusive. So this should give us a 3-column table of the 2nd, 3rd, and 4th columns. Okay, so select is the way that we can bring back specific columns. And you can tell it which columns you want by using their position number. I wouldn't suggest you do the position number often. Now, the reason for this is data changes. It won't be your data always. People will muck about with your data sets. They will move things around. If you're only going by the positions of the columns, somebody updates that data and moves things around, those columns will no longer bring back what you want. So it's safer to use the names of the columns if you know them. Okay, well, you will know them. But it is something you can do. So that's why we show you here. You can also do the inverse of this. So here we've taken the beds data, then we've selected and we've said not, by using minus, not org code. So what this is doing, what dplyr doing here is taking all of the columns except for organization code. And so it's giving you the other ones, date, organization name, beds AV, and OCAV. And again, you could do not and then do multiple ones. You could do a range of ones that you don't want, for example. And that's a nice little way of doing the inverse of selecting what you don't want. There's also a select everything. So this is it seems a strange way to do this, but actually it becomes very useful. So imagine we wanted to reorder the columns in our data set and do so relatively quickly. But we've got a 100-column data set. We do not want to be writing out all of those names. So what we can do, select the one we want, then comma, and everything is a particular function, and therefore it has brackets at the end. We just put that after org name, and then everything else will be put after org name. Generally speaking, in the order it was in the original data set. So rather than having to write out every single name of the columns that you want to go after a particular one or before a particular one, you can do this, which can be a nice little shortcut too. And then it starts to get kind of clever, okay? So we can do little things, and I don't know if anybody does this in SQL. Let me know what the equivalent is, because I've done a bit of SQL, but not loads. Here we can have a sort of matching criteria. So when we were doing filter yesterday, we were saying filter on rows where date is exactly the same as a particular date. Here we're saying select columns that match this condition. And the condition we've given it is that it starts with, written with an underscore. So starts, this is in blue here. Hopefully you can see that it's in blue on my screen. And that means that it's a function. It starts with, and in brackets, it starts with this string org. So as you can see, this has brought back the two columns that have org in their column name. And funnily enough, because it makes perfect sense that there would be, there's also an ends with. Okay. And so you can see how you can start to build these things up. If you're not sure what functions are available, we'll come back to how you find that later on. And but always try the most common sense version first, okay, because it's probably called the most common sense version. Okay, so I want to select columns that start with org. The function is called starts with. Okay, R is really nice like that. Not all packages are, but tidyverse generally is. And then instead of starting with or ending with, we can look within a column title as well using the contains. Here we wanted any columns that contain this string s_a. Turns out there's only one because here's the s_a that exists in beds AB. So this will just bring back that column, but all the rows, because we haven't said to filter on any rows at all. Okay. So this is like a contains is quite a useful one if you're not sure. Yeah, Nicola.
So you say it's a wildcard. You don't have to put the percentage sign or anything in. So just S&A is all you need. You don't, and then it knows to all the characters afterwards.
Yeah.
Okay.
Exactly. So contains is an easy way of saying it might be anywhere in this string, but it'll be S_A in that order that we're looking for. But you could do that looking for any combination of letters and symbols and numbers and whatnot. If you know what you're looking for, you'll be able to use contains to find it.
Yeah, because I think in SQL you had to put the percentage either at the beginning or the end to say whether it's prefixes or ends.
I think that's quite common in other languages as well, which will be why Zoe popped it here as percent wildcards. A lot of the regular expression stuff, have you heard the term regular expression? Regular expression is horrible, but very useful. So regular expressions are a way of, how would you even describe regular expressions? It's like a symbol-based understanding of strings. And it's quite common across languages. And this is one example. I'll not go into it too much now because it's not that useful to you. Right. So again, today, just a reminder to stop me anytime you're not understanding. I'm going too quickly, anything like that. We have two other functions now. We have an n with curly brackets, and then we have the n__ distinct with curly brackets. These do different things. So we looked at summarize yesterday. Summarize is going to take your whole data set and just give you and smush it down into what you've asked for. It's not going to give you all the rows of data back again. So we're taking our beds data, then we're going to summarize. And within our summary, what we're going to do is create something called number. And we're going to say number equals this funny little function n. And this comment here, it's a comment because of the hash. Anything after this will be ignored if we pressed run on this. This is going to bring us the distinct number of different organization names. So this is the number of organization names, sorry. Then the next thing we want to create in our summary is something called distinct_number. And funnily enough, we'll use the n distinct function of organization name. So what we're asking for there is within the, and because we're using the .by, we're using it within an organization code, how many different organization names are there? Unique organization names. That's what the distinct means. And with this function here, we've then gone on to filter, which you all know means look at the rows and only bring back the ones that match this argument. We want to only keep the rows where the distinct number, that thing that we just created, is more than 1. And then, just for fun at the end, apparently, we are going to arrange that data set by the descending, order of the distinct number column. So this I find much, much nicer than the bit of SQL that I did, that we can create these things on the fly and use them within the same piped function. And that's really, really quick and really nice. Let's just do this.
Sorry, Claire, before you move away from that.
Yeah.
In a layman's term, how would you read out what you just showed us there?
This code here?
No, not the code, the output. I mean,
the output. Okay.
Yeah.
So this is
you want to put it in a report. How would you read that out?
Yeah.
I'm trying to understand what we're doing here.
Yeah. Let me show you. Tell you what we can do. This is the quarto that we created yesterday. Yeah, this is the little, we're not doing quarto in the slides right now. I'm just jumping over to the quarto report that we created yesterday, just to show you how to do this kind of thing. So if we are within an R chunk, remember the chunks are there to be the code-based element. Anything outside a chunk is just writing like you would have in Word. So in this code chunk, let's say let's create something called a table. A table this is the assignment operator, and I'm going to make a data frame with 2 columns. One is called X. X is a combination. Don't worry about the things I'm showing you here necessarily. 1, 2, 3, whatever. And then I'll have a Y thing, which is a combination of 4, 5, 6. Okay. If I run this, it'll spit it out into the console. Okay, so that's the table there. If we wanted this to show in our report, what we could do is then say table underneath, because when we call back this thing that we've made, it's saying to it to print it. That's a little bit confusing in the minute because it's not set up as a workflow for you. We'll come back to this at a later point this morning, or maybe slightly after midday, and explain that again. Okay, so I'm just showing you quickly to show that all of this is doable and to create it in a way that is savable outside, if you like. So are you thinking about how we would put it into a file that we can save outside of RStudio? Is that what you're asking?
No, not how you put it in a file. How you'd write about it so that a layman understands what that table is telling us.
Okay. I think I understand your question. So it's not about the content of these data, it's about this table. So what we're showing here in this output from the hash downwards is what R is telling us is we have a table, which we know is a type of table, that is 22 long, 3 wide, 22 rows and 3 columns. And it starts with it's got these 3 column names, org code number and distinct number. And these columns are of these different data types: a character, which is CHR, an integer, and another integer. Then by default, it shows us row numbers here. And then we have the actual summarized data. So we'd asked it to summarize by organization code, which is why organization code is the first column. And so we will have 1 row for every organization code, and then we will have the results of these things for each organization code too, which were the number, N. N is just giving us the number of rows that there were. And then the N distinct is giving us how many unique organization names there were within that organization code. And this is just showing us a little snippet of these data. And therefore, this bit at the bottom is saying, by the way, there's 12 more rows there that I'm not showing. Is that all right? Is that kind of what you mean? I don't think I've been really answering your question. Sorry.
No, okay, I'll leave it for now, because what I wanted to hear was, if you're reporting, you said this table is showing us, is it 21? It's telling us that each organization has got 21 distinct names, something like that.
Okay, so no, what it's showing us is each of the organizations has this many rows in the original data. So all of them look like they had 21. There were 21 rows for every organization. But for the organization with the code RDE, there were 3 distinctly different organization names. So let's go to the data, the beds data. So this is the organization code R1A. Let's, if we, in your viewing of data, by the way, you can click on these and it'll reorganize, it'll reorder. So you can see this organization code TAJ here. There's lots of different rows of it, probably 21 because of the table that we just saw. And there's this organization name, Black Country Partnership. Now it looks for that one that there's only 1 distinct name for that organization code. Let's put it. And here again, for ROA, there's only one organization name. But we know from our table that there are some organization codes that have multiple organization names. So doing this would be a way to see there's some that have two names, two names per organization code, and some have three, and most probably have one. Remember, we've ordered this table by highest to lowest number. So the highest number is 3. At maximum, there are 3 distinct organization names per organization code. That makes sense? Hope so.
Yeah,
If not, we'll come back
does,
to it.
It does. No, it does. Thank you.
Good. No worries. Good. Oh, cold lens as well. Right. That's the end of that section. How did that feel? Did that feel difficult or easy? We introduced you to select and combined it with some of the stuff we did yesterday with filter and summarize and all this kind of stuff. Are you starting to get a little bit of a feel for the machinery that we've got here? Give us a little thumbs up if you're all right with that so far.
It's like everything. In principle, it makes perfect sense.
Yeah.
Then you just need to break it a few times and attempt to do what you're trying to do, I suppose. So, yeah, it's good so far. Thank you.
Good. Okay. Yeah. 100%. That's a really good point, by the way, Patrick, because you do have to break things a lot before you start to feel comfortable. Never be scared to break things when you're doing coding. It's really, really valuable learning, which is why we want everybody to ask these questions, to shout up, to make your mistakes and do them in public, as uncomfortable as that might be to begin with. Right then, next section is about objects. We created some of these already, but we'll come back to talking about them more specifically now. So R is an object-oriented programming language. Objects that are created from imported data appear in the environment pane, which you already know, this pane up here. So we've got these 3 objects, a beds data, a by ethnicity 2, and a capacity AE object. Okay, these objects all happen to be data frames, tables, but objects can be anything. Oops. And we can create objects from code very easily as well. This code, this type of code that we've been running, don't worry about how complicated this one looks. What we've asked it to do here is take something that already exists and do stuff to it. And it will give us the output in the console. What we haven't done is changed anything about the original data. Okay, so we have just done this on the fly, and it's shown us in the console what that would look like if you did that. What we haven't done is overwrite the data in any way. So we would go back to the beds data and it would not be summarized. It would not have this percentage occupancy column yet, and it would not have this arrange. And obviously that's not something you're going to want to do often. You're going to want to change the data carefully. So we talked previously yesterday about this assignment operator. Okay, in R, the assignment operator is this left arrow, so what's that, a less than arrow, and a little minus sign, one straight after the other. It's conventionally used instead of an equals, although in certain circumstances equals will work as well. But get used to using this, because what you're saying is you're saying I'm creating this thing, and what this thing is this, and the this comes on the right hand side. So there is a shortcut for whoever asked for it yesterday. I've never used the shortcut because this is 2 keystrokes basically, and this is 2 keystrokes, so it doesn't feel like a shortcut to me. But personal preference, use a shortcut if you'd like. What we're doing in this little code snippet here is slightly different. So before we were just going from here down. Now we've prefaced this with something called bed occupancy. So we've just come up with a name. And we've said, okay, we're making this thing called bed occupancy, and it is whatever happens when you do all of this. We know that this code produces us a table with certain features. So if we tell R to do this, essentially we're saying take that table that you create as part of this big bit of code, and that thing, that object, is now called bed occupancy. So let's run this and show you what we do. So we can see this here. Is this big enough for everybody, by the way? Remember, we can change sizes and colors and whatnot. If anyone's struggling to read this on my screen, give me a shout. I'm not sure if it's big enough. It's very pink as well, which you might not like, but I'm quite enjoying today, so we'll stick with it unless anyone objects. Right, let's see what happens then when we run this bit of code. Let's do it run a different way. So I'm going to just have my cursor somewhere in this and click run. And you see it's run that whole chunk of code because this is one long thing with all these pipes doing sequential operations. And look, it's created a thing for us. Okay, so this is the bed occupancy object that we've just created. And we can see it's a thing, it's a data frame that has 255 rows and 4 variables. Kaylee, was there a question?
Please, could you add the code to the chat?
Yes. You should all have the code and the slides and all the rest of it as well. But yes, we can add this to the chat. I have to come out of sharing to do so. I think I do. Right, there's the code in the chat there, so you can copy that and pop it in. Tell you what, let's make a couple of other quick and easy objects just to show you that it doesn't have to be something big and complicated. So I'm going to create something that I'm just going to call X. X is 2. Okay. I press run on that, and something has popped up in my environment. Now it knows X is not a table. X is just the number 2. So it's created a different set of things here called values. And it says there's a thing called X, an object, and what that thing is just the number 2. Now I'll create something called Y. Y is the letter A. There we go, we've created an A. I think we'll come back to doing this in the, probably getting ahead of myself with the slides. So we're making objects in a minute. This is the name of the game for this section. Now, so this is something that we came across yesterday, wasn't it? Is naming things and how hard it is naming. The way names are written out is a question of style. You might find some ways nicer to look at than others, but whatever you choose, it's really best to be consistent. Oh, I'm going to sneeze, sorry. All other ways of writing names will work, but avoid all capitals. So SQL people will be very familiar with writing things in all capitals. We don't like that in R. Makes things complicated, but also avoid spaces. So the most common different naming styles we've got in R, something called camel case, where so you start with a small letter and then any new word begins with a big letter, sorry, I have an 8-year-old, an uppercase letter without spaces. So that's what's called camel case. There's Pascal case, which is similar, but it also starts with a capital. There's snake case, which is what I like. I find this much clearer to read, where everything is lowercase all the time and words are separated with an underscore. You'll find a lot of people use this snake case. Snake case is kind of default for tidyverse as well, I think. And then there's kebab case, which is a silly name really, but that has these hyphens between words. Again, whatever you're going to do, just stick with it, make it clear, and ideally do the same as what your team does. It'll avoid a lot of problems later on if you stick with a kind of style like this. Oh, end of that session. Right, let's just play around here a little bit. So we just created a few different things here. We created an X and we created a Y. Let's create a Z as well, just for fun. It's also a number. So we've also got the number Z. The number Z. We can do things with these now. So if I say, because it's in our environment, our session knows about these. So I can say now, X plus Z. And if I run that, what do you think will happen? What's the answer? X plus Z. Anyone remember algebra? The answer is 12, because X, it knows, is actually 2, and Z is actually 10. And I asked it to sum them. And so it's just adding those things together. And we can start to build up any combination of objects and relationships between them using their assignment rather than the value they're in. It starts to get really, really powerful. We can also overwrite these very, very easily. So if I said now Z is actually a pair, Z is now a pair. So if I then try to do the same thing again, X plus Z, what do you think might happen? Will the answer still be 12? The answer will not be 12. It's going, I don't know how to add together something that's a word and something that's a number. And the way it says that is, this sounds like a really unhelpful error, but you get very used to this error in R. So non-numeric argument to a binary operator. So it's basically saying to us, I'm expecting a number and not getting one, which is absolutely right, because Z is no longer a number. That's, yeah, we'll come back to more object stuff in a moment. The objects are a really, really powerful, useful thing that we start doing a lot in R, and it's how we start to move forward with our coding. Let's go into the next section. Everyone okay with pace this morning? Anyone need a breather? I think the breaks we did yesterday worked quite well, didn't they? So we went till 10:30 yesterday, but if that's feeling like a long way off, let me know.
Sorry, just a quick one.
Yeah.
The font in your bottom box in your console, I can't see it. I'm struggling to see the colour. Sorry.
The colour. Okay.
It's
no worries.
when you were typing in it. Is it blue? I can't.
It is blue, but thank you for saying, because not everybody can see this very well. So let's go to Tools, Global Options, Appearance, and we will find one that we all like and that works nicely.
It's just it blurs into the back.
Yeah, no, absolutely. It's probably a lot easier for me to see on my screen as well. What looks nice? Does that look nice? It's you can play around with these and choose different ones. Maybe I'll just have a white background today, and it might be better. Does that look clearer in the background?
Yeah,
there?
thank you. Yeah, cheers, thanks.
Awesome. Feel free to do this on your own as well, on your own version of RStudio or Posit Cloud, to go into Tools, Global Options and have a play around, make it look nice for you. Okay, vectors. Vectors sounds really scary and mathsy. It's not, don't worry. It's a type of data format in R that might be familiar to you. It's basically, it's a free floating column. In common parlance, it's like having a list of things. So you can create a vector really, really easily. And I used this when we were doing that little bit of quarto earlier, using this C function. C stands for concatenate. I think. Oh, well, there you go. It stands for concatenate. In SQL, it would just be curly brackets, apparently, with no C. So here in this little bit of code snippet, what's happened is we've created 3 different vectors. One is just some numbers, one is some words, and one is a mix of things in a vector. We can combine any number of things. We could have a vector that had a table in it as well. It starts to get a bit complicated, but useful. So vectors are quite powerful. If we are looking for more than one string, so here we've got a vector that's got 2 strings in it. String, by the way, if most of you will know what that means, it's just characters, basically. It's writing, it's letters. And strings are always combined, are always contained within quotes, be they double quotes like these or matching single quotes. So here we've got Bradford District Care and Bradford District Care Trust. Okay, we can make this into a lookup. So you'll all be using lookup sometimes, which are tables of reference data. So here we're creating an object called org lookup, organization lookup, and we're saying org lookup is that vector. Let's see what happens when we do this. Get rid of all this stuff. So if I just run the C line, the line 1 there, it's just going to show us the output of that. We're not asking it to do anything. We're just saying we haven't even given it an object. We're just saying, here's a vector. But if we assign it to this object called org lookup, hopefully you'll be able to guess what will happen here. We've now created an object in our values list. It's not a table. Otherwise, it would be up here with the data. It's in the values set. It's called org lookup. And R here is telling us that it's a character that only has 2 elements within it, which we know because there are 2 things that are surrounded by quotes. And they're these 2 things. If I start typing org in my console here, it now knows there's a thing called org lookup. So you can see that it's auto-completing for me. So I'll just press enter and say, yes, that's what I want. And if I just press enter now, it's going to return what that thing is. Okay, so it knows that this thing called org lookup is a vector of 2 strings, these strings. Okay. So this is going to be really powerful for you when you're trying to only bring back certain data. So filtering, as we know, is selecting certain rows. So filtering by the organization name that is within our lookup is probably you'll be able to guess what this is going to do. So the beds data that we had before, then take the rows, filter, only those rows where the org name, the column org name, the element that the organization name is in, and it's a special type of in surrounded by percentages, the org lookup that we made. So let's do that. So I want to take the beds data and then just tell me which rows are the ones where The organisation name is either this or this. And there we are. So there is a tibble whereby the organisation name is Bradford District Care Trust or Bradford District Care. This org lookup can be whatever you want it to be. And this percentage in, and you can see it's in a slightly different colour here. It's maybe not as contrasting when you're seeing it, but it's showing us that this is a functional thing. This is like an operator, like a plus or a minus, or this is going to do something. So we're taking rows where the org name, and this needs to be a column in your data set, is in this vector organisation lookup. Okay, it's a common thing that we do. And in SQL, you'll be familiar with this. So select everything, which is what the star means in SQL, from table, whatever table you've got, where the column is in these things. So that would be what the exact equivalent would look like if you did it in SQL. Whereas we've got only 2 lines here, and we don't have to write out this. We're just using org lookup, which is the object name we gave it. We can inverse that really easily as well. And generally speaking, the inverse is whenever we see this exclamation mark. I'm going to sneeze, but it's not happening. So here we're asking, as you might expect, for give me back the rows where the organisation name is not in the organisation lookup. That'll give you all the other rows. So I'll just add an exclamation point here. The exclamation point, if you're negating something in R, usually it would go right before the operator. So sometimes if we're doing double equals, as we said yesterday, that is saying is exactly equal to. If we're saying is not equal to, we do exclamation point equals. Whereas with the in, the exclamation point needs to be at the beginning of the little sentence this year. Let's run that just so you can see, not lying. Okay, so now it's returned to us a little table that has all the rows where the organisation is not one of the ones in our organisation lookup. Dead quick and easy, nice and logical. And apparently this is what you would do in SQL. You just have not in and then spell out what it's not in, which is the list of different names. And that's all we have in that little section as well. We're hoping some of these things that we're doing are things that you guys do in your daily job quite a lot, and so you can see the utility of them quite quickly. Another common thing we do is we join stuff together. Bane of everybody's life, joining data tables together. It can be really difficult, it can be really complicated, and there's a lot of different ways of doing it. But Tidyverse, our mega package, and dplyr have some really nice ways of doing this and make it, I think, more simple than any of the other languages that I put in. So it's rare to find all data that you need for an analysis in a single table. And typically, you have to link 2 or even more tables together by a common key. So example being, you've got patient's data where the patient is identified by their NHS number, and then you've got a different table that's got NHS number and address or something, and you need to join their medical details to their address. So you need to stitch those 2 tables together using the key that is their NHS number, because that's the thing that's similar between the 2, well, the same between the 2 tables. In SQL, we use joins, and this in Excel would be your VLOOKUPs and that kind of gubbins as well. H lookups in X. I don't think I've ever done an H or an X lookup in Excel. You guys are, I saw from yesterday that a lot of you are better in Excel than I am, so you'll know more about that than I will. All the joins in SQL that you can do are obviously available in R, and they're called mutating joins. A couple more are called filtering joins, and have some of the same concept as the exists when it's used in the where clause. And that'll mean more to people who do a lot of SQL. But don't worry too much about that terminology. You don't need to memorize that. So here's a nice little diagram for how we would do something called left join. This is the most common one. So imagine again your tables that you had where you have your NHS number and the patient's medical stuff, and then a different table with the NHS number and their address. Depending on which table you want to be the main one, a left join will keep all the rows in that table, and then it will join to it only those rows that match on the key from the second table. And this is what this is showing you here. So we can see this table that begins on the left with 1, 2, and 3. Apologies if anyone's red, green colorblind, but 3 is green. And what we're doing is we're noticing that the two tables, when they begin, only have rows 1 and 2 in common. So when we join those together, because the table with 3 in it is on the left, we're going to keep all of its rows, but only join onto them the rows from the second table where they match, which is rows 1 and 2. Okay. We would write this quite easily by using left join, left underscore join. We can do this in a couple of different ways. So I've got some tables here that haven't got anything in common, I don't think, have they? So ignoring that I don't have data that I can use as a nice example for this. If we were going to join two tables together, we could start off just saying left underscore join, and we join table X to join table Y. We could do it like this. And the left table is the one on the left, so X would be the left. And we would take the rows from Y where they match with left based on the key. So, for example, the ID. If there's a column called ID that exists in both, or the NHS number or something like that. So we're saying take all the rows from Y that match in their ID with the rows in X. Or we could write it like this, left join X to Y. But what we like to do is to pipe, because we think in stages, right? Like our mashed potato recipe. So we could take table X, then left join it to Y. And R knows that you're taking the thing, the X thing, and that is the left table. And then you're left joining it to this thing called Y. So you don't need to repeat X in here. That sometimes confuses people a little bit, but it shows that we continue to have this flow of instructions. But this is also absolutely valid and does the same job. Whatever is easier for you to understand. Does everyone get that before I move on? Hopefully joining things is something you've done a lot of. Right. Oh, question. Go for it, Aslan.
I mean, the shorthand version that didn't have like the ID column that you're joining on.
I'm sorry, I can't hear you. You're really, really quiet. Are you able to come closer to the mic or turn your volume up? If not, don't worry, we can come back to it later. So you can type it into the chat perhaps, and then Kaylee can pop her hand up for you. I couldn't quite hear you there. Sorry, my ears are quite fuzzy today as well, so I can't really. Okay, so that's left joins. What do you think we do the opposite way around? We can do right joins too. Okay, so we have 3 data sets in our intro R data project that you all created yesterday, be it on Posit Cloud or locally on RStudio. And we're going to try joining these together. These tables are all about tuberculosis, which is why they're called TB underscore something or other. And they're country level data with one population by country. So I'm going to give you 5 minutes to do this, because you won't remember everything that we did yesterday to import data, but I want you to make your best guesses. Have a go. You're probably right in your best guesses. Okay, so I want you to import these files, first of all 3 of them, into your project that you're in at the moment. Okay, I'll start the timer now, but I'm still here, so shout if you're having an issue. Give it a good go first yourselves, though. Yeah, Cram.
Hi, Claire. So we're just doing the import for now. The rest
Yep.
we'll do later, right? Okay, perfect.
Yeah, and if that's been dead easy, great. If everybody's done with that, put your hand up or thumbs up or something so I know, and we'll just move straight on. Laura, that's cool. Maybe there's a few seconds first. Jenna? Oh, no, that was a thumbs up one, wasn't it? Sorry.
Yeah,
That was a
sorry.
bad thing. Yeah. I realized I shouldn't have told people to put their hands up to tell me that. It's not very helpful. Yeah. It sounds like most people are there then, so that's probably fine. Okay, so hopefully you managed to import those data sets. Let's remind you how to do that quickly if you're struggling. So if you're in the project that you created yesterday, Intro to R data, so to remind you to get to that, if you're on Posit Cloud, go to your workspace. You can click this to see the left-hand column as well, but it's not too useful in this context. And you should have an Intro R data folder. You might have also created an extra project. It's not going to be in there. It's going to be the Intro R data. This is where the data that we need is. Let it start up, and we can see these tables down here, but we haven't created them as objects yet. So we can do that by importing them. So the import dataset wizard that we used yesterday is up here. They're CSVs, so they're text files. So let's use Reader if we can to import them. Browse to where they are. Let's try this one. So the tuberculosis cases, TB cases, is a 3-column table. That looks sensible, isn't it? This is a character column. This is double and this is double. Country, year, and cases. We don't need to skip any rows or anything like that. You could just use code to do this using the Reader package, in which case you'd do TB cases. That'll be what your table will be called as an object. Is read the CSV called TB cases, funnily enough, and then we can view it. Okay, so let's import that one, and we'll do the same to the others. Cases, wasn't it? So we'll need new table. And then we'll do the same for the third one, whatever it's called. Pop for population, probably. Yeah, looks like population counts. Again, looks quite sensible, so let's just import it. Okay, hopefully you all managed to do that easily enough, whichever way suits you. When you are joining two tables by columns that have the same name in both the tables, R just knows that, and you don't have to tell it which columns to join by. So if you have a column called country in each of the tables, you don't have to tell it to join by country. So when columns have the same name, R resolves this conflict by adding an X and a Y to the end of the column name. So I just confused you by saying the opposite there. It's a nuanced thing that actually, ignore what I said. Let's do it from this direction. So both of so we're taking the TB cases data first. Let's have a quick look at it. TB cases is in our list of things here. So we've got country, year, and the number of cases. We want to join that using a left join, so we'll keep all the rows in TB cases no matter what, to the TB pop column table, which looks like this one. So we've got country again, year again, population count. So because we've got year in both of those data sets, it's going to append the name year with a .x or a .y, depending on whether that version of year came from one table or the other. So we've got now the country column, which is the one we joined by. So both of them had country written like this in them. So it knows that that's our key, if you like. And then it's giving us all of the rows where country matched between the two tables, with the year that came from TB cases, now called year.x, the cases from that table, year from the TB pop table, year.y, and then the pop population. So that's a quick, simple left join to show you. You can join in multiple columns. So because year is in both of those data sets, we're presuming that if you're joining these, you want to join them based on where not only the country is the same, but the year is also the same. So we can join by a vector, remember vectors, of different column names. So here we know country and year should be similar between the two tables. So we just pass it to the by argument of the left join function using this concatenate. By is a combination of country and year. So there's been an update since 2023 to make this even easier to write. So we've got the TB cases table. Left join it to the TB pop table, please. Joining by, join underscore by, country and year. And here the difference in syntax means that we don't need to wrap these in quotes anymore. The reason it's doing this probably is because when we wrap things in quotes, it's thinking of a string, whereas a column name from a table is like an object in R. It knows what you're talking about. It's not a string. It's not just some text. It means something to the program. So we can join these things using something like this. Let's run it and show you what happens. Get rid of all of this to start with. So take TB cases, which we have. This won't work unless you have imported this table. Left join it to TB pop. What do we get? We get the combined table that we were talking about. Because we joined by country and year, we no longer have the two different versions of year still in the table. We've got year once, and then we're only seeing rows where the year and country matched. Questions? Karan?
Yeah, sorry, I just ran that code and not with the join, but just with the TB. Can I just share my screen for one second?
Of course,
Sorry.
please do. Yeah.
So I just did this TB cases and left join, and it gave, I think this one, it's saying, is the code field okay?
It does. So you're joining cases to pop as the case to pop continue. Yeah, so what that's doing, if you scroll up a tiny bit in your console to the top of this message. Yeah, so again, remember yesterday we were saying that R is quite chatty with you. So it's not stopping you doing this join, but you're getting a warning message, which is really, really helpful. What it's saying is when you left join TB cases to TB pop, there are multiple rows that match. And what it's saying there, you can see in the warning, it's detected an unexpected many-to-many relationship. Many-to-many relationships happen. So it's not the case that country A only exists once in table, sorry, country in table A only exists once in country in table B. We've got many versions here and many versions here. And the reason for that is because of the year column, because they're supposed to match on both. So it's giving you a lot of information here. It's not saying it's not going to join them, but it's saying, oh, by the way, did you realize that there's a many-to-many relationship going on here that you didn't tell us about? Is that what you're expecting? So it will still join these tables. And if you go up a little bit, you'll see that the table has been created. But it's just checking with you because usually when you're joining things on a key, it's only expecting that key to appear once, and it's not anymore in these tables because year match as well. So that's a really, really helpful question to ask. Thank you. That is worth spotting and worth pointing out.
Thank you.
It's a warning, not an error. So it has done the thing, but pay attention to the warnings because they can be really informative. Somebody else had their hand up, but they popped it down. Whoever it was, do you want to still ask a question?
No, I sorted it out.
Oh,
Thank
well
you.
done. Mm-hmm.
Sorry.
No, don't.
May I ask a question, please? Sorry.
Yeah, of course, can. Mm-hmm.
Can I share my screen with you? Sorry.
Please do. Yep.
I am battling. I'm nearly there with what we're trying to execute now, and I've got all sorts of errors. I think I'm not typing things very well.
Mm-hmm. So, are you typing it straight into the console to do this?
Yes.
Okay. So let's start with the first one that it went wrong for you on. So TB cases, then left join TB pop by country. So what you've got this one essentially, yeah, you've got this bit of code halfway up your console screen. Let's put it into a script to make it easier for you to see where you've gone. So if you click on your untitled one script, which is in the top left bar, yeah, and let's pop it on a new line in here somewhere. The TB cases, and let's type it out. Let's do it together. In fact, I'll do it with you. So TB cases, and if we do TB underscore, it knows we've got something called cases, so we can autocomplete. Then, what are we doing? We're just joining it straight to left joining it, left underscore join. See, I've got a little red cross here. It's because I've not finished this, and R knows I've not finished this. So that's
Sorry, I can't see your screen.
Oh, I'm not sharing your screen, of course, never mind. Okay, yes, so then left join. So left underscore join. And in curly brackets, TB pop.
You say in curly brackets?
Yeah, normal brackets, yeah. Sorry, normal brackets. And no space after the word join. Yeah, and it's TB underscore pop is what we're joining it to. And then comma. We're saying the key for these is the column country. So by equals.
Do I need spaces?
Don't worry about it there. You don't need spaces there. R is fairly permissive. Is that an equals or a minus? I can't tell.
That's equals.
And then in speech marks, the word country, lowercase c.
Yes. So we run it.
Right. Yeah, run that. So this is good. This is useful. It's telling you that it can't find the function left join. So any idea why that might be? Why can't it find the function?
I had a quick look. The package wasn't available. It says that the dplyr wasn't available, but I did add it by now. So I don't know what his problem is.
So you've added dbplyr. dbplyr is another very useful package, but it's not the package we need.
Sorry, so this one I want.
Yeah, dplyr. Yeah, exactly. And there, it's giving you lots of information about what's happened as you've loaded dplyr. It'll tell you about masking and blah, blah, blah. Try again now. Try and run that line 14 in your script. There we go.
Magic.
No worries. So for everybody's understanding there, we were trying to run something with a function that comes from a package that we hadn't loaded. And so R doesn't know what you mean by left join unless you've loaded the package. So that error message is kind of useful. It's going, what is left join? Don't know. You're like, well, it comes from this package. So please make sure let's load it.
Thank you so much.
No worries. Nicola.
Just to warn everyone, yesterday I was doing the deposit and it said it needed to be updated. And then afterwards, nothing worked. So I just had to reinstall something. So just to warn everyone else that sometimes when it doesn't update, the stuff that you think you've already installed, which is a library for the tidyverse, had to be reinstalled. So just in case it does it for anyone else.
That's a good point as well. I don't know if we come on to that in these slides, actually. So I think I'll talk about that now, actually. So, is this a good time to do it? Will it confuse people? So the reason you had to do that, Nicola, is that R works in sessions. Okay, so when you start up a new session of R Studio, if you haven't loaded your data from the workspace, remember we ticked that don't reload straight from the workspace button in the first session. It's starting up a fresh environment, as it were. The packages that you loaded last time don't exist yet. Yeah, you've installed them. They're in your library in the background, but you haven't pulled them out of the library in this session to open them and start using them. So you need to reload them in a new session. Okay, that's why at the top of a script, we usually have all of our library calls collected at the top of a script, so as that when we open a fresh session of R Studio, we just run those lines and those books are taken out of our library and opened so we can use what's in them. That's probably the simplest way I can say that, I think. We might come back to that. I don't think we have extra slides on it, but it's a good point. Right. So we have joined some tables together. Let me share screen again. And we've done it based on two columns that match in our data, country and year for this one. And we can write it. This is the better way to write it because it's more up to date, more fancy code with the join underscore by. I still do this again because that's how I learned. And this still works, as you've seen. So dplyr joins can occur automatically. This is what I was talking about before when I confused everybody. So the column country with lowercase c exists in both the tables that we're trying to join together. Let's just and because of that, we don't actually have to say to R, by the way, join on the column that's the same. It's going to assume that we mean that, okay, which is great, really useful. So in this call to join TB pop to TB cases, we haven't bothered to specify by equals country because it's going to know that it's country and year. These are the ones that match between them. That makes life a little bit quicker, a little bit easier for us, and a little bit more sensible. What if, though, in table A, let's call it, TB cases table, you have a different word. You've got country is the name of that column in that table, but in the other table, country spelt wrong, or it's region or something or whatever, but it's got the same contents in the table. You still want to be matching, you still want to be linking by that column. That's still your key column. This is how we do that. Let's show you this one. So we're still going to take our TB cases. We're going to left join it to the something called TB new table, which is one of the tables we haven't used yet, but we did import earlier on. And what we're doing with by here is join by, where country and the first name comes from the left table, which is the first one we've talked about, is the same thing as what's called place in the second. And in this example as well, year is spelled with the lowercase in the TB cases, but in the TB new table, it's spelled with an uppercase. Now, because R is quite exact in its matching of strings, if you didn't tell it this, it would go, well, there's no such thing as year with lowercase in the second table, so I don't know what I'm doing. So we're just specifying here that the country and the place columns are actually the same data. That is what we want to link on. They're called different things in the different tables. So this is how we get around that issue. Remember, the double equals is telling us is exactly equal to. So there's another type of join called a semi-join. And again, you can see here a nice little GIF of what this actually means. They retain the data in the left table if it matches the right, but drops the right. So it's not like an inner join that keeps both sides. Okay, so an inner join is terminology that you'll use in other languages as well. Inner join, unlike our left join that will keep all the rows in the left-hand table no matter whether they match something or not, inner join will only keep rows where they match on both tables. And a semi-join, as we see here, is doing something in the middle of the two of those. So all rows from X where there are matching values in Y, keeping just the columns from X. So we see we're getting rid of the column from, we're not duplicating the columns from Y again. Does that make sense? The joins are quite tricky to get your head around. If you're struggling with this, I recommend you come back to these slides at a later date, because the concept of the joins is the same between languages. It's just getting your head around what you're trying to do with it. Left join is by far the most common, or inner join is by far the most common thing that you'll use. Let's see an example. So, hospital COVID tests. So finding hospital patients who've had a COVID test, but only bring back the information on the hospital and nothing about the test. This is the task that we want to do. So we want to join to the TB new table and bring back only those records where the column first letter is the string A, but drop the data from TB new table. Let's have a quick look at TB new table, because we haven't looked at that yet. This is TB new table here. It's got a row per country, it's got a year, and it's got something called first letter, which is just a letter, first letter in the string. And so again, join to the table and bring back only those records where the first column is A, first letter column, excuse me, but drop the data from the TB new table. So we don't want to keep this data, but we do want to know that the rows in the TB cases are the ones that we are looking for. So we're going to create a new data frame doing this, and we're going to call it lookup table. Lookup table is assignment operator. Take the new table, TB new table, then filter as in only bring back the rows where the column called first letter, and this is Pascal case it's written in, which is exactly equal to A. Let's run this little bit first of all. Okay, we'll run that. Okay. So it hasn't spat out an output down here because we haven't asked it to. What we've asked it to do is to make an object called lookup table. Hang on. And here we have lookup table in our list of datasets. Lookup table is just a little table that is 4 observations and 3 variables. Let's have a look at it. It's just Afghanistan because that's where the first letter. Oh, that's why first letter. So first letter is the first letter of the name. I didn't spot that. First letter of the place name. Silly me. Okay, so it's brought us back this little table. And the next thing we're going to do is take TB cases and semi-join it to that little table we just made by the columns where country in TB cases is the same thing as place in our lookup table, and year with lowercase y is the same as year with uppercase y. Hopefully you're all managing to code along and do this together. If not, don't worry, you'll be able to do it another time. And again, we've not assigned this to anything now. We've just asked it to do this. So it's giving us a little output here. And it has brought out, so our lookup table was 4 rows long, and it's brought back 4 rows because it's taken those ones where TB cases matches lookup table based on these things being the same. Hopefully that's relatively clear. If not, don't worry, we're going to have a break soon. You can come back to this. Okay, an anti-join is kind of an inverse thing. So we want all the rows from X where there are not matching values in Y, and just keeping the X rows that refers to. So I'll let you watch this GIF a few times and see what we end up with. We've got X and Y table, but we're going to match them together, but we don't want the matching rows, we want the unmatching rows, but we don't want to keep anything from Y. We just want to keep things from X. Yep, so we're just going to end up with that row 3. There we go. Okay, and that's what's called an anti-join. And again, anti-joins happen all over the place, not just in R. This is just how we implement that in R. Here's an example. In text mining, you may or may not come across text mining, we exclude little words that don't help us much. So the ands and the ifs and the buts and the ors, those kind of stop words as we call them. And all the stop words are kept in a separate table, a reference table of stop words. So we now want to join TB new table to TB cases and exclude only those records where the first column, first letter is A. So we're taking TB cases and then anti-joining to lookup table where these match based on country, place, year, and year as we did before. Have a look at this in action. Here we've got what that comes back as, which is a little 12-row table, 3 columns, country, year, and cases, as we would expect. This is the rows but that don't match, essentially, and keeping only the information from the original TB cases table and not the lookup table. And don't worry if you're going, in your brain at the moment. A lot of people do at this point. Doing joins and figuring out what you actually want to get back is a lot of trial and error sometimes. You get much more used to it as you're doing it. Some of these joins, I don't know that I've ever actually done an anti-join in Anger, but I'm showing you them to know that they're there. Maybe you use them all the time. Don't worry about knowing about them in detail. Just know that it's something that can be done. And it's easy to implement in R because R is lovely. Okay, so that's the end of that session. There's some links here to be able to see these again in Anger, just so that you can get more used to them. And we will go over them again in the Intermediate to R course if you're signed on to that. So you should be able to get some more experience with them. Kaylee.
Hi. Oh, my voice went then. Hi, Claire. Could you just clarify why we're using by and join by together in this join?
Yeah, it's a new terminology that is part of the updated syntax, and you don't need to know more than that. It's just how it happens. You don't need to use the join by, as we say. If I go back to those previous examples, you can just use by in a string, and this is what I do because because this is more updated, and I learned way before 2023. So the join by, it's more formal syntax. And it's easier to do, so it's best practice, if you like, but it's confusing. I know it looks like you're doing the same thing twice by saying by, but there's no more reason for it than that, as far as I'm aware. There may be, somebody's probably written a blog about it somewhere. I don't suppose it's terribly important though. Okay, any questions at the moment? Great, we're at 10:20. Oh, Kaylee.
Could you please explain right join?
Yep. Let's do it based on what left join is. Where's my nice little GIF about left join? You want a GIF about left? There. Hello? Sorry, I heard
Women as in West Midlands. You need to take advantage of 20.
Oh, somebody's got, if you can mute something, I'm hearing something about the West Midlands. Which you may want to be talking about, I don't know. So left join is this one, as we've seen. A left join, we're saying join these things together, but keep all the rows from the left-hand table. Right join is the opposite. It's keep all the rows that match, but all the ones from the right-hand table. So it would be doing the same thing, but we'd end up with this little cartoon, we'd end up with rows 1, 2, and 4 instead of 1, 2, and 3, because 3 comes from the left table and 4 comes from the right table. Generally speaking, right joins are unusual just because if you've got a reference standard table and you want to join something to it, you'd always start with that one, right? You'd say, take this important table and then stick something else onto it. And so the important table is always the left one. So you're pretty much always doing left join. You can do right joins if you want to. As I say, it does that. But if you're always using that convention that you take the thing you want to keep and then you join something else to it, then that would always be a left join. Because the thing you talk about first, X in this case, is your left. And so a left join is most appropriate. But right join is there and it's called right join because that makes sense. Right, I propose 15-minute break now because we've come to a nice segue. Any questions before we do that? Everyone happy to go and have a cup of tea? Cool. Okay, let's come back at 10:35 then and we'll do a little bit more. Thanks, guys. Hello, everybody. Hope everybody's filtering back in. Managed to get a cup of tea and a break. Let's crack on again. Let's go. Okay, so before the break, we were joining tables together, which is a really common thing that you'll all be doing in your day-to-day lives. And we've got lots of different handy little dplyr functions to do that with. We're going to change tack now a little bit and talk about styling your code. Styling seems initially like a frivolity. It actually isn't. So you're going to need to read your code. Others are going to need to read your code, whether they're doing some QA on it, whether they're picking it up and working with it. The whole point of what we do with code is to minimize human error. One of the ways we can do that is make sure that the code we write is very, very clear and we can read it clearly. Part of that comes from the styling that we use. Let's talk about that a little. So there's an updated version of the book, R for data science, which gets initialized to R4DS. I'd really recommend you read this book. Let me just show you actually if I Google it. R for data science. It's an online free book written by Hadley Wickham, who's a guy I mentioned the other day, who is the father of the tidyverse, basically. So this is the book. It's all here, really available. It's written in really, really accessible language as well. So don't be intimidated by it. And this is the second edition of this. Oh wait, that's the second edition of this book, and it's really, really helpful. It's a tool that a lot of us come back to. It's got a Kia on the front rather than the other bird to show that it's the second edition. I think that's a Kia. Hey, I'm not from New Zealand. Okay, so there's a code style section in the second edition because Hadley and others realized the importance of having a style for that readability element. And it mentions the styler package. So remember that curly brackets here means a package. So we have a package, and our package called styler. When we run that package, it becomes an add-in in our studio, and I'll show you this in a sec. And it automatically applies the tidyverse style to our code. Tidyverse being that huge package with lots of other packages, and a really important thought group, if you like, in the R world. And they have their own style of writing code, and you can apply that style to existing code that you've written using the styler package. So let's do that. We're going to install the package styler. You can do it any way that you like to install packages. You probably have your own way by now. So there's ways you can, I think it's in, no, it's not in file. There's an install packages in tools. You can use the packages tab down here on the right and click install and put styler in there. Or, as I'm going to do, you can put it into the editor and run it, or you can put it straight into the console and run it. And it all does the same thing. Let's install styler package. And again, as we've said lots of times now, it's set up to automatically go and get this from CRAN, the Comprehensive R Archive Network. And there, it's done it, dead quick. Nice. So it's gone away and it's got that package and it's put it into our library, as it were. My Teams things there. Right. When you're looking at our studio, near the top, under Profile and Tools, you'll have this little button called Add-ins. It will have things in it to start with, but once you have installed the styler package, it now has a little chapter that's headed styler. We have these options within it: set the style the selection, the active file, and the package. So everybody who's coding along with this, install the package and just prove to yourself that you have the styler section in there. You should also have like maybe some other ones. I'm not sure which. Anyone who's struggling with that, let me know.
Sorry, I managed to install it. Can you just show me how to? You just click something to see some options.
Styler creates add-ins, and add-ins live in the add-ins tab here at the top of your R Studio. So this is I'm in Posit Cloud here on this one. This is where add-ins are for that. If you're using R Studio locally, we also have an add-ins that's on this top bar here. Okay, I haven't installed it. Let's install it here as well. Install.
I'm struggling to see in the studio, but that's just probably me.
Yeah, it's up here at the top. So along from where your new file is. I haven't put it into my local one.
I got it. Yes, yes, yes. Thank
you. I'm going to install packages in quotes because at the moment our studio doesn't know what kind of thing this is. I'm going to say it's styler. Press enter, and we'll install it here as well as on the Posit Cloud. Well, this is slower than the cloud. It's telling me that it's downloading styler from CRAN, and it's downloading all the rest of its dependencies. It's giving me a message here. It's saying these packages will also be installed. Okay, so these per cache, methods S3, and all these other bits and bobs are needed for the styler package. And it's saying to me, these will be installed if you do this. Do you want to do that? And I'm just going to press yes and enter. So it'll go away and install me all those dependencies. And there, successfully installed it in seven packages in 2.6 seconds. Yours will have a different speed. Some of you will be on proper old potato laptops, so it'll take ages. The styler's only a little package, so it shouldn't take forever. Let's have a look at my add-ins now here. When you're doing it in your R Studio, you're going to have to restart R, okay, before it'll pick up this change. An easy way to restart to create a new session is if you hold down Control, Shift, and then F10, and it'll restart the session. And ideally, it'll now have styler in our add-ins. Another way to restart the session is to go to Session at the top here, and you can just restart R. Or you can just shut it down and open it again, whichever way. Some of the changes that you make are changes that only take effect on the startup, and so you need to start up R up again to do that. So as I think it was Nicola mentioned this morning, I've restarted this session now. So although it's kept what's in my environment, the libraries that I loaded before won't be anymore. So if I needed to do the same things again, I'd have to reload those libraries. But hopefully I'd written them at the top of whatever script I was writing. And so it'd just be a case of rerunning those lines. And it would be dead quick and easy. So we've got the styler section. So indentation in R, the number of spaces in from the side you start doing things. R Studio does this. It helps you with indentation to get it right. Okay, so it automatically indents according to the function and the bracket positions, and it makes it correct for you. But you can also highlight some code and then press Control and I, and it applies the indents for you. So if I started to say, I still got a thing called X. Yes, I do. So like X is X plus 5, whatever. And if I had put that like this, okay, so I'd split that over 2 lines. This is not usual syntax. I would have it all in 1 line, or as you saw, because I'm not finished this phrase, if you like, it should have been like this. So what I'm going to do is I'm going to highlight this and do Control I, and the Control I has shifted it to where it's supposed to be. So if you're ever not sure about whether the indentation you've used is right, you can highlight that section and do Control I, and it will apply that indentation for you. Okay, now we've got a little task for you to do. So let's look at automatic indentation. You've still got the beds data, hopefully. If you haven't anymore, because you've started a fresh new session, it'll be within that intro R data project that you set up. And in your console, you can write beds data, then press return and see where the cursor goes. Then type beds data pipe, then hit return. Where does the cursor go now? Then do this whole thing here, beds data, then select organization and organization, as in type all this out, be it on a script or in your, well, do it on a script, it'll be easier on a script. And put the select on a new line, then put org code onto a new line. Then eventually put this little bit of text into your editor as well, and use the Control I and see what it does. So have a little play. It won't take 8 minutes for you to do this. I'll give you 5, but I'll start the timer and stop it at 3 minutes. Okay, have a little go and let me know if you hit any snags. If you've whizzed through that and you've managed to do all that and you're quite happy to move on, give me a little thumbs up, let's say, or a non-hand up emoji of some description, so that I know when we're mostly there. That's one. Nicola. Linda, you have your hand up. Is it a question?
Yeah.
Mhm.
Doesn't seem to apply the indentation when I do Control I.
Are you doing it in a script in your editor, or are you doing it in your console?
The script.
Okay.
Like share my screen.
Yeah, please.
This one.
Mhm.
So I wrote that, and if I highlight and do Control I, it's not.
So that's because it's already happily indented correctly. So if you take away the space before select, on line
Okay.
38, yeah, so that's kind of not wrong. It would still work, but it's not indented nicely. Then you press Control I. It's going to shift that over to make it look prettier.
I see what you mean. Okay. Thank you very much.
So, no worries. So the whole point is to make it look like a flow, essentially, so your eye can pick up where the start is and what we do next and all that kind of thing. Give you another moment. I'll pop the link to R for Data Science in the chat as well, just so you've got it. Param?
Hi,
Sorry, I know I'm not
just,
pronouncing your name right, am I? Is it
sorry,
Param or is it Horam?
it's a glottal, that's fine, Horam. So just want to check, so if I'm doing it right.
Mhm.
So do we just first put the whole thing in one line and then put the select in a separate line?
You can do. The point of this is just to play about, to realize that you can do it wrong and the Control I will help you indent correctly. So whatever you started with, just have a go and see what it does. If it's
And
all on
if
one
I-
line, then it
if
won't
I-
need to indent anything because you can just write everything in one line. But we'll mention
Okay.
why maybe not to in a moment.
So if I do that and then I do Control I.
Yeah, so that's already indented correctly because
that's
select
already-
is yeah.
Okay, perfect. Thank you.
All right, let's move on. Everybody managed to have a little play. Space code. That sounds like a fun title. Using spaces, not in names of things, but generally speaking, now it helps with readability. So R, like I was saying before, unlike some languages, is quite permissive about where you put spaces. It's quite happy for you to do that, and it'll still usually run whatever it is you've asked it to do. But spaces help us as humans to understand what's going on and to see things more clearly. So the code below will run, but R doesn't need spaces to work. So look at this code, okay? We've got this one long piped thing. Isn't it ugly? It's horrible. It's really complicated. I mean, if you write this kind of stuff, you feel like you're quite clever because you've written something really complicated, but it's not easy to see what's going on. It's not very nice. Let's just prove to you that it will run. Oh, things closed down 1 second. Come on. In its own time. Getting there, sorry. Okay. Let's put that great big long, and I'll stretch this a little bit so you can see. You'll notice a couple of things here. A, this is gross. It's really squished. It's really complicated. You'd have a trouble understanding what this was doing. It's not nice. You'll also notice in your RStudio, there's this line down here. This line is a helper. There's a, what's the word? Not standard, but essentially there's an accepted length of lines of code beyond which people generally find that it's too long and it shouldn't be that long, just for style purposes. So this line, it probably has a name, sorry, but I don't know what it is. This line is just grey. It doesn't do anything. It's in the background to help you know that if your code is over this line, it's probably too long and you should probably split it over multiple lines, because as a human, you don't want to be scrolling side to side to know what the code is saying. Where this is at a standard length, generally speaking, but you can change it in your options as well if you want to. So this is gross. It's also used this operator. So it's saying create a thing called beds dataset, which is, and it's going to assign this as an object, because like I say, we can use equals, a single equals as an assignment operator. But I don't know about you, I find it a bit more complicated because equals has different meanings, whereas the assignment operator just does that one thing of creating new objects. The beds dataset is, and then do this whole gamut of ugly, gross things. Let's run it. So it runs fine, repeats what we've done here, and we should have something in our, we have the beds dataset here. So it has worked. It just looks horrible. And somebody reading your code is going to go, what is that? And what is it doing? So after it's been written, if this is somebody else's code and you're like, yuck, that's gross, putting spaces in can be a bit of a pain in the bum. So this is one of the good things that the styler package is there for. So copy the code. I'll put it in the chat for you. Copy this code into your editor. And once you've got styler installed, you may have to restart R, like I said. Load the library and then go to the add-in and drop-down menu and select style the active file. And I'll give you a few minutes to do that. Everybody understands the goal? Any questions about that while we're doing it? Good. It's obviously very clear and you're all very clever. Style is much more important in other languages that are much fussier about indentation and whatnot. We spoke a bit with Quarto about YAML, which I now realise the YAML stands for yet another markup language. Hilarious name. YAML is its own different thing, and that is very fussy about spacing and indentation and whatnot. As you've seen, R isn't. It'll still run. It'll do the right thing. But for us as humans who need to read the code, it's gross. And so we're doing this to make it more readable for ourselves, more easy to debug as well. Again, gives a signal if you're already done with this. Right. Horm? Tried.
Oh, sorry, I was just checking if we can have the code, but I think Harriet has put the code in.
Oh, thanks, Harriet. Sorry, I forgot to put it in the chat then. You don't want to have to write it out again. It's grim. Nicola.
Mine's not doing anything. I did a restart and I've reinstalled the stuff that I needed to do, but it's not changing anything. So I don't.
Let's have a look, shall we?
Yeah. Hold on. This is where I've got to try and figure out which screen I'm sharing.
Yeah. We're here.
There we go. Right. So I've got the text there. It's come up with an error message, so I presume I don't need to sit on anything. And then I go into here, and I'm assuming it's supposed to change it, and it's doing nothing.
Is this the whole of the code? Does it end with that bit, descending percentage occupancy? If you scroll to the right on your code. So
I've copied it from above. Have I missed anything out?
I don't know. That's what I'm saying. Let's go to the end and see. No, it looks fine. It looks like you have got it there. Okay. And have you loaded the tidy bus again?
Yeah, I did. I thought I'd done everything, so I did it on the right hand side as well, just in case, because each time I do it, it seems to be saying I need to. Well, so I've selected it, but then I'm coming to here and thinking I have to do it again. Oh God, not that bit. Where's my packaging? Right, so do it that way, just to make sure it was doing it.
Yeah.
So it's doing that, let's just say it. But each time I do it, it keeps saying I need to restart it. Is it? Yeah, and I've got this
Can I
again.
see your add-ins drop down, please?
Yeah. So it was showing it as though it's there.
I can't see your. Oh, right. Yeah, it is. So let's just click Style Active File from the drop-down menu.
Yeah, that's where it comes up with an error message. So
is that what you're doing?
Yeah, so it's as though it's there, but it's not quite doing it. I mean, I know it's trying to do, and it's not, and it works. I wouldn't write it that way anyway, but something's not quite work. And I did the there's a style thing as well there. So it all looks like it's. Is that the other one? I'll just check just in case it's something else missing.
You've definitely installed Styler, so that's
because the thing's there, and it's
not
I've
for some
done
reason
about 3 reboots. So
no, it'll not be a reboot released issue, I should imagine.
No.
What it's not liking is Patrick.
Is it something I've pasted in?
Patrick,
sorry, I've got an error message as well. The one I typed in the chat box. I don't know if it's the same one.
Styling or unsaved
just
files,
copy it again from the box, just in case there's something.
Patrick, your one is just that you need to save the file that you're working in first before it'll let you use it.
Right. Okay. Thank you.
No worries. I'm not sure why it's not liking your pipe operator, because you have something on the right hand side.
Just repaste it over the top in case I missed anything.
What it'll be, why don't you delete everything else in this file apart from the horrible long thing? Because what you've probably got somewhere else in this file is a pipe operator that doesn't have anything on the other side. So yeah,
just create another script.
Sure, yeah, that's fine.
Yeah, I kind of been putting notes on the other one, so
okay, keep it. Yeah, make a new one then. And let's copy and paste the horrible thing into there.
There you go. Yeah, it's just that. So I can just say that's something else.
Yeah. So you will have had somewhere above that the pipe operator.
Something that's not liked. Yeah, that I've not finished off. Yeah.
Yeah.
Okay, fair enough.
Cool.
Okay, cool. Thank you.
Rightio. I'll steal the screen back again if that's all right. And we shall move on. Oh, well, we shan't. End of that session. Okay. So, styling is important. It seems frivolous, but it is important and it is useful. You want to be creating code that is readable to humans as well as to your colleague. They are humans. Readable to you as well as to other people, and make sure that debugging is easy. And it's a lot easier if things are long rather than wide. Patrick.
Sorry, I've got another error after saving and everything. I've just popped it in. It just doesn't like something. Yeah, it's the same error that we had just there. So something in the script, somewhere above this, you've got a pipe operator that doesn't have anything on the right hand side of it, and it always needs to have one. So I would just delete everything else that you've got apart from the great big long line, because the error is not happening because of this bit that we're working on now. It's because of something else that's in your file further up, and it might be that you've been playing and doing other things. Sure.
Asan?
Yeah, sorry. Yeah, it did start it for me, but then the code doesn't run for some reason.
Do you want to share your screen?
Yeah.
I don't know if I haven't done it myself, have I? So I don't know whether it's fine to run.
Yeah. They did start it. But then when I try to run it, it just gives me this errors.
Okay, so that is telling you in the error message something about the data. So it's saying that there's an invalid type. It's saying a character. We've tried to sum a character column. Now, this bit of code, we're only using it for the purposes of showing you styling. It's there's something wrong in the code, and that doesn't really matter to us right now because we're not trying to create Bed's dataset. We're not going to be using that for anything else. But what that error is telling you is that you've asked for a sum of something that isn't a column with numbers in. So essentially, I wouldn't worry about that right now, because again, we're just showing it to show the styling. Okay, Hurrah.
Yep, sorry, Claire, can I just share my screen for a second?
These are really useful errors you guys are getting, by the way, so I'm thrilled.
So I've got the code here. So if I select it and do Control-I?
No, so we're not trying to indent this code. So indenting is for
everything other than the very first bit. If you've got a really long string of information and you want to have it lengthways, you want the bits under the very first line to be indented a bit so you can see where the very first line is. What we're going to do is style the whole of this script. Okay, so you can style the active file, which is the one where your cursor is blinking. And that should, if everything else is right in there, and yes, just say yes if it's not got the package that it needs. It'll take a moment because mini UI is actually relatively large. So all we're trying to do is apply that that style guide that Tidyverse uses. So try again.
Okay.
Because you've got the mini UI now, so it should happen.
It didn't do anything.
It didn't do anything, did it? Maybe because you've highlighted this part. So yeah, without the highlighting, just do the style active file now. If that doesn't work, there we go. So
there you go.
Done an ugly thing though. That's odd. But it has styled it, right? So oh no, it's not. It's fine. Yeah, it's fine. So what it's done is it's split it over multiple rows.
Yeah.
And that is allowing you to see the verbs, the dplyr verbs more clearly. So every row starts with a new verb. Verb is not the word they use in the package. It's a function. So summarize, then mutate, then arrange.
Mutate,
so we can see the order nicely. Mm-hmm.
Yeah, brilliant. Thank you.
Cool. No problem. I'll do mine as well, just for fun. Yes, I want to install mini UI. Go on. The elements. So you don't need to be applying styler. You can just write in a good style. Oh, great! I've got an error. Never mind. Oh, Moksha, sorry.
Yeah, sorry. I think I got an error message, and after saving it, my error message has slightly different. Changed.
Okay.
That is a new one. Shall I share my screen?
Yes, please. Yeah. Let's have a look.
This is one. So I saved it and then run it again.
Mm-hmm.
That is the message symbol not correct somewhere.
Okay. So to be clear, I reckon, because it's got a lot of stuff in this script and it could be being caused by anything, I would have the code that you want to style in a new script, or just delete everything else in the script as well. Because it's not liking a space before bed occupancy, and it might be, there's a lot of things that could cause that essentially, but it's not worth bothering finding out. It's probably just
okay.
As long as you don't want to keep that stuff.
No, I don't really want to keep it. It's just kind of a style. Try to find out what the style is doing.
Yeah, exactly. So if you just delete the extraneous stuff and try again, hopefully that will fix it. Oh, oh thank goodness. Right, and you'll need to save it, and then start an active file, and you can do that from the add-ins. Let's hopefully, there we go. So it's split it over those.
All right. Thank you.
No problem. Right. So I want to just highlight a few of these elements of the style, because you don't need to use the styler package. You can just write in this style, and I try to as usual. Operators, that means symbols that are going to do something. So we're talking plus, minus, all that kind of stuff, and operators like this, assignment operators. It's big enough. Have a space before and after them to make them sit out nice and clearly. Pipe is an operator as well, so it's got a space before it. Generally speaking, after a pipe, start a new line. And as you saw in the activity we did earlier on, when you do that, it'll automatically put the cursor to the right indented place so you can start typing in the correct place. So equals is another operator, so spaces before and after. You can split things over multiple lines. That's fine. R doesn't mind that. It'll still run. And like I say, after pipe operator is a common one. You can also do it anytime you've opened a bracket. You can press enter and it will indent that further because it knows that you need a closed bracket before you're finished. So this is carrying on. So you can split a line after you've opened a bracket. You can split a line after a comma. And again, it's going to indent it a bit further there because it's waiting for you to finish that sentence, as it were. It looks a bit ugly like that, but I'm just showing you the different options of how you can split things. Go back to where we were. So having things long, and obviously this divided by is also an operator, so have it with spaces. We've gone over this line here. So usually what I would do is to, again, split this long summarized line. And a bit like when you're splitting things in Word and you put a big word that would go over the edge of the page, the whole word on the next line. After an equals, you can also press enter and start a new line. And there we've got a much more clearly set out thing. Actually, I'm going to disagree with myself. See, in the summarize, we're doing two different things. We're creating total beds and we're creating total occupancy. If we're doing the same thing repeatedly, it's kind of nice to have them in different lines. So there's three elements to this summarize. We're going to make total beds, we're going to make total occupancy, and we're going to do both of those by organization name. So that kind of splitting looks nicer to me. It looks more clear that we're doing a similar thing twice. And so that's one version of style. You'll have your own probably. Tidyverse style is useful, is what is used quite a lot and is coming around to be, there's no such thing as rules of how you have to do this stuff. But you might want to get used to looking at it at least, because you'll see it a lot in the things that you'll be learning from. So we were done our style code, weren't we? Yes. Right. Let's move on. What time are we on? 11. Right, fine. Okay. This section is all about you supporting yourself from this point on to start playing and start know how to find the answers to the questions that will inevitably come up for you. Lots of ways of doing that. So how do we find out what a function does? We've got lots of options of doing that. If you type a function, this is a ggsave function, and your cursor is within it, blinking away within it, you can just press the F1 key. What that will do is it'll bring up the help that is written about that function. So every package, 3dplot2 here being the package because it's in curly brackets, every package has to have a help file, and the help files have all got a standard structure. Let me show you one. What have we, let me go into Posit Cloud because that's where I was working before. So let's say summarize, okay, and I'll bring this a little bit closer. At the moment we're on the packages pane, and the help pane will just be basic help. We don't need to go to that to start with. Let's stay with files. My cursor is blinking away on the summarize. Let's press F1 because I can't remember what summarize does. Here we go. So the help tab is now highlighted, and it's going to take us through what summarize does. Okay, so it's got the function name, it's got which package it's from, which is the dplyr package, and then it's got a description of it, which should be written in nice, clear, plain English. And it's already telling us here what we found out on the first day as well, that you can use an S or a Z, American or English spelling. It's absolutely fine. Then it gives you a tip as to how you're supposed to set this out. What is summarize expecting to be given to be able to work? And it's saying here it's expecting some data. Don't worry about the fact that it's dot data. And then what you can do is summarize by something. When you're seeing this, it's giving you what the defaults are. So default is null, as in it's you're by default you won't be specifying by. That means summarize the whole table. There's another default called groups. And then for each one of the things you have to give it, or you could give it, it's going to explain those arguments, what it's expecting from you. So the data for summarize is expecting a data frame extension, like a tibble that we've talked about, or a lazy data frame. Don't need to know about that. And it gives you lots and lots of different bits of information about each of the arguments that goes into it. And the values, it's what's going to come out the back end of it. After you've run this, what's it going to give you? And it'll explain what it's going to give you. Give you some other useful functions that come from the same package. And there's lots of other things written. What I want to tell you about is to go straight to the bottom. If you've never used a function before and you want to see, okay, well, show me what it looks like when you do it in reality. Examples is really, really useful. So I find myself, if I'm using a function I haven't ever used before or that someone's just made, I'll go to examples to see how to actually implement that. So you've got lots of different things here that you can look at. MT cars is a data set that comes as standard with R. So here you can use summarize in this way. Usually you'll want to group first. So this is the old-fashioned way of doing it, remember? So MT cars, and this is the old pipe as well. Group by cylinder, then summarize. The mean is the mean of the whatever disp is. And a thing called N is the number of rows. Remember that N thing we did last time? And so the examples is really, really useful. And every single package that's on CRAN at least has a similar looking help file. And so you put your cursor there, you press F1, and the help file will come up. It's one of the ways that you can find help with something. There is also, as it says, shows here, there's a search bar in the help tab in RStudio as well. You can just type in the thing you want to find, as you would do with Google. In the console, if you want to, the other way of finding help is to start in the console, not in the background jobs. Start with a question mark and then put the function that you want to see the help file of. So let's say filter. We know there's a few different types of filter. So what it's going to do is say, okay, are you meaning the dplyr version or the stats version? Let's say the dplyr version, and that'll take you to the help file of dplyr. Okay, so starting with a question mark and then the name of the function is another way of getting to the help file. If the package hasn't been loaded up, so if you haven't done library dplyr, then the help file that is contained in it is still in the book, and we haven't opened the book yet. But you can ask it to go to your library and look at it in two different ways. One is to use do you remember this double colon syntax from yesterday? So the double colon means a specific thing in R. It means from this package, I mean this function. And we need to do this if we haven't loaded the function, because we haven't loaded the function. Those functions that are in that package are not available to us natively yet if we've not loaded it. So we can say, okay, from the beeper package, what does beep mean? Beeper package is super fun, by the way. Let me just quickly show you the beeper package. It's really stupid. I've actually used it in anger though. So let's install it. Install.packages beeper. Let's go and get the beeper. Okay, so let's load it as well. Library beeper. So now that I've loaded it, I can use the functions without doing beeper : : So I'll just say beep, which is one of its functions. If I press enter, it doesn't work. Couldn't play the sound. Oh, audio drivers, I'm online. Let's do it here instead. I mean, this is a long-winded way of making a noise, but I want to show you because it's fun. Install.packages beeper. Go and get me beeper, please. Yes, I want to proceed. There, and then let's load it with library beeper. And we'll do beep. And it didn't make a sound because I'm sharing on Teams. The beeper package makes noises, okay? There's lots of different noises it can make. This is a real digression, I'm sorry, but I've got to tell you this. If you're creating code that takes a long time to run, what I've done at the end of a function that takes a long time to run is have it make a noise, so that if you're going to make a cup of tea, once it's finished running, it'll go da, 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 or something, and you'll know to come back. So just a fun little package. Why were we talking about that? I feel like I've gone, oh, because of this. The other way to find help on a package, on a function from a package that you haven't loaded yet, is to use double question marks. So this is the function name. Beep is the function name. So if you're not sure which package it comes from, which will be a common thing, there's billions of them, double question marks, and then the function name. That'll take you where you need to go. So there's lots of places to find help that is not just the help files, if you want further examples and whatnot. RStudio community is a really good one, and you'll end up going to this website called Stack Overflow. This will be a lot of the examples that you get when you Google something. Stack Overflow is a coding website. It is there to help people who use loads of different types of languages and loads of different codes and whatnot. Let's show you. Have you all heard of it? I don't know if I'm preaching to the converted here about Stack Overflow. Yeah, people have. Okay, so Stack Overflow is basically a question and answer place. So you can search for anything you like. You can add your own questions to it as well, although there's a style that you have to adhere to. And Stack Overflow is a really good place for answers about different R-related things. Not even just looking for how does a function work, but which function should I use for doing X, Y, Z. So we link to that. And then this is a really good plug for our community Slack group if you're not already a member. Again, because you guys are here, and this course is being provided by NHS-R, which is myself and Kaylee essentially, and the community. You probably already know about the Slack group. You might already be in it. We have the Slack group for a reason, and that is because the community helps the community. It's much like you guys have been helping each other when you've had issues today and yesterday. The community is there to support each other. We're a big community, but so many people like you are at the very early stages of learning R. And sometimes you really need to ask a stupid question. It's not a stupid question. And you also know that there'll be a lot of people with the same stupid question that aren't brave enough to ask. our NHS-R Slack group that hopefully Kaylee can pop the link into the chat here again, is a really, really nice place to ask some questions, especially if those questions aren't easily Googleable, if you see what I mean. And you can't find answers on Stack Overflow or anywhere else. We've got a particular help with R, I think it's called, channel within there as well, which is you can ask questions in the general chat too, but help with R is for particular types of questions that are naughty and interesting about R, but really, really welcoming, right? So if you know the answer to someone else's question, go and answer it. You know, it's a really nice place to be, and seeing other people's questions and helping answer them can help you learn really well too. And other good places to get lots of help. Popular packages, especially CRAN ones, have cheat sheets, and these can be really, really helpful. And they're available as downloads. So what is this link? This is the link to the cheat sheets. There's loads of them. So let's click on one. Is there a ggplot2 one? Because we'll end up using ggplot2 in a minute. There is one somewhere, but I can't see it right now. Not to worry. Let's just do this one. Oh, it's not the actual one. Cheat sheets are packed with information. So yeah, they're tricky to read, but they can be very, very helpful, especially when you want to know at a glance what's possible with this package. And that's great with plotting packages as well, because you can see lots of examples of diagrams. So to find the cheat sheets, you can just Google it, essentially. They will come up. But also, if you know it's a CRAN package, why not go to CRAN that we saw yesterday, the main site for getting our packages from. Let's have a look at packages. Let's do it sorted by name. We'll go to the G's because ggplot2 is the one I want to find. We'll go down. Let's look at all these packages that we give with the G. It's crazy, isn't it? And still in GE. You can search as well, but I'm just giving you an idea of how many we're talking about here. ggplot. Where are you? Come on. Oh. Aha, ggplot2. This is the standard, what CRAN will show you about the package. It looks really uninteresting, doesn't it? Really boring. But it gives you lots of information about the package and who built it and when and all that kind of stuff. There's also always a URL to it. So this is the actual website that ggplot2 lives on, and it's Excel, and it's GitHub. So this is where the code that makes ggplot2 lives, and the cheat sheets are in here. Okay, so cheat sheets can be dead useful. Seems like a change of pace. Save your script. So think of your script in the editor as the real part of your analysis, and it's just a file that will save as a .r. So in your version of RStudio, please do save your files so that you can come back to them later. So this one here, my test.r. Again, you can save it by clicking save there. You could click save there. You could, while you're in it, do Control S and save it. And let's have a look for that on, oh no, I'm not on my actual computer. Let's see, I haven't saved this one in the quarter document. I've now switched, sorry to switch around so much. This is my local version of RStudio now, because this is where we did the quarter work yesterday. And I haven't saved yet this quarter document. Quarter documents are QMD. So I'm just going to Control S on this and save it. And I've saved this file now, and I just want to prove to you that it now exists as a file. Wherever I put it, I'm going to put it in there. Testing quarter. Okay, so there's the QMD there. Is that what I call it? No, that's a QMD file. Yeah, so I saved a QMD file, and now I can open that again and have a look at it anytime I like and modify it and whatnot. So saving your work means you can go back to it, and unlike with Excel, you know exactly what steps you did to create your outputs because they're right there, written out and commented, which is lovely. I've already mentioned some of these books already, so this one is my absolute fave. R for Data Science. You might not be a data scientist, you don't need to be. It's really, really beginner friendly book about using R for analysis as well, and it's free and available online. So I'd really recommend having a look at those. Data visualization, if you make a lot of plots, there's so much you can do with R in plotting, and R is probably one of the best plotting languages. And then again, fundamentals of data viz. These O'Reilly books are really, really good, generally speaking. There's lots of them, and we've put the links here. So you've got all these slides, you should be able to get all these links as well. I'm not going to do an art interlude or computational art interlude. Oh, Coran?
Sorry, Claire. So if, for example, I didn't close my file from yesterday and everything I've typed now today, the save button is not clickable anymore. So only save as is you can do. So would it save all the stuff I've done today?
So if it's grayed out, it means it thinks it's already saved. So I would convince yourself of that by going into your file explorer to where you would expect it to be and just making sure it's there.
Okay.
It will have saved, yes.
Perfect, thank you.
And but if it gives you a save as, that's just like with any other program, it's just allowing you to save it again as something else, called something else or somewhere else. Okay. Cool. So just to reiterate, the point of this course is not for us to teach you everything. Obviously, there's literally infinite things you can do and learn with R, but I want to get you guys to know enough to be dangerous, that you will start trying things out and learning on your own, because we all do to some degree, and that's the most fun way as well. Let's have a look at some ongoing learning resources to that end as well. So it's not unlike learning a spoken language. We've said that before. It takes time to build up the vocabulary and learn the syntax and all that kind of stuff. And you need to use this in your daily life to get more comfortable with it. You cannot expect to even do this course for 2 days and then come back 2 weeks later and go, oh yeah, no, I know what I'm doing with R. Absolutely won't work. It'll reward you the more you put in, like everything with life, basically. Quick fixes. What if you get stuck? Google it. I Google things all the time, as we all do. Stack Overflow is your friend as well. As I've said, Stack Overflow requires a vocabulary to describe the problem. It helps you through it. Like if you want to post a question, it will double check that question hasn't been asked before, and then it will tell you that it needs you to ask the question in a specific way, and that's so that the people that come to answer it have all the information they need straight off. And it's not a case of going back and forth for ages, them saying, oh, can you tell me what your system looks like? Can you tell me this, that, and the other? There's also more than one style of writing R, as I've said. People get quite opinionated, as they do about everything, but stick with your style that works for you and for your team. Where are the data? Oh, yes, on Stack Overflow, some of the questions have been posted years and years ago. So although the answers might have been appropriate at that time, it's worth checking if they're really old answers. There aren't something more up to date, because these packages get improved and added to and updated all the time. So look at the name of this. This is a question someone's put on Stack Overflow. Group by multiple columns and some other multiple columns. That's a really, you have to sit and go, wait, what? What are you trying to do? If you just said that, if you just said, guys, how can I group by multiple columns and some other multiple columns? You'd get blank faces, wouldn't you? It's very, very tricky. So it structures the question underneath in a way that allows people to actually understand what you're trying to do. There's longer term fixes. These 2 books are really great. Hadley Wickham, I'm such a fangirl. Hadley has written great books. We've already talked about this one, the ggplot2 book. We'll talk about ggplot2 a bit more in a minute. It's also excellent for graphics. There's the Big Book of R. All these links are available to you on these slides. There's loads and loads and loads of blogs. We've already said the NHS-R Slack and the Government Data Science channel on Slack as well is very, very useful. Some of you might already be in that, actually. Here's some useful presentations as well. Jenny Bryan is one of POSIT's developers as well. She's got a presentation on how to name files. So it sounds like a really simple thing. It's actually harder than it looks. Naming things is generally hard. Danielle Navarro as well is a well-known name in this area, which has got a presentation based on Jenny's on project structure. Remember we talked about how to structure a project? There are templates that you can use, and there are agreed ways of structuring a project that make it easy for someone to pick it up and run with. So have a look at some of those links too, and that is enough of that. Right, now let's get on to some fun stuff, shall we? Because that was all a bit dry. Get rid of these cheat sheets. Let's make some plots. Everybody wants to make plots. Plots are lovely. Okay, ggplot2. ggplot2 you'll have heard a lot about. I've banged on about it a lot already. Ooh, hello. This session that we're going to talk about is basically chapter 3 of the O'Reilly book, written by Hadley, the R for Data Science book. So again, have a look at that book in your own time, and hopefully a lot of it will seem familiar after you've done today's course. There's lots and lots of different packages for plotting in R, and other people will use different things. So there's things like you can plot just using base R with no additional packages. You can use ggplot2, you can use Plotly, you can use Leaflet, you can use lots of different things, okay? I'm just going to show you some ggplot2 now because it's the easiest way to get started. ggplot2 is obviously the more updated version of the original, which was called ggplot. Why is it so popular? Well, it's really well designed. It's really well supported and maintained. It's got an active group of developers that make sure that they're addressing any kind of bugs that are found constantly. It's really highly versatile, and its default graphics are really, really attractive. Unlike some packages where the default, if you don't do all the work to create the nice colors and all that, it just looks rubbish. Whereas ggplot tends to be so nice in the defaults that you just run with it and you don't need to do anything else. There's other, I think these are little explainers as to why to use it as well. BBC uses ggplot2 for all of its graphics, and these are examples of ones created with code using R, using ggplot2. And you can look at this website, you can Google this. It was last updated in, well, I think it's probably got a more, this is a screenshot of it, it's more up to date now. They've developed an R package themselves and an R cookbook to make the process of creating publication-ready graphics in their in-house style, their own style, using ggplot2 a reproducible wrap process, as well as making it easier for other people. So you can get the BBC's style package and make BBC style plots yourself using ggplot2, which is really nice. It comes, because it's so popular, packaged within the tidyverse, so that's nice. So if you have already loaded and installed tidyverse, you've already got ggplot2. You didn't need to do nothing else. Right, let's start with a wee project. Now a drink. Pressures in A&E. Common thing that people work on. So we have demand. We have people turning up at A&E all times of the day and night. We have a certain amount of capacity for coping with those people, be it ambulances, be it chairs, beds, and all that kind of thing. We have a certain flow rate of patients going through. We're going to be using the capacity and A&E dataset that we all saw was within our usual project to do some of this stuff. And what that shows is changes in the capacity of A&E departments in 1 year, from 2017 to 2018. The object named capacity AE is a data frame, as we've said, and it is in tidy data format. So let's reiterate this. It's a standard way of mapping the meaning of a data set to its structure, says Hadley. Each variable is a column. Variables are the things like ID, name, and color in this little example, and each observation is a row. Each cell is a single measurement. That's the tidy data format. A tibble is a type of data frame. We take tibble, as I've said, to be synonymous with data frame, but it does a few extra things. Don't worry about it. It's just a data frame. So let's have a look at it. So hopefully you all know how to import that data set into your R. So please do go away and do that. And I'll do it too. We don't already have it, do we? No. Okay. I'll show you my way of doing it. I don't usually use the wizard, but we'll use this today. We'll browse it, the capacity AE CSV. Let's open it and see whether it looks sensible in our data preview. So it's got a number that's called site attendances is a number. There's a logical, which again is true falses. Yep, it looks sensible. D cubicles is a double and D weight is a double. If we wanted to use code to load this in, we could use this code here. Let's just import it as it is. And it has added it to our list of things that we have. Okay. Got quite a few of these now. I should remove them. If you want to remove data sets or objects, you can just do in the console, you can do RM, which means remove, and then in brackets the name of the thing you want to remove. So I'll remove beds data. Yeah, no, I'll remove the other ones because I don't think we use them again. I remove TV pop, and it's gone from my list. And you can combine them. So let's remove. So that one's already gone. Let's remove new cases and TV cases and the lookup table. Just creating a little bit more space. So you can see the capacity AE data set a little more clearly there, which has apparently 68 observations of 5 different variables. Let's click on it and have a look at it. Let's go to these two. So we've got different sites. These look like they are unique site number identifiers. We've got the number of attendances in 2018. We've got whether, I don't know what the definition of this, whether the staff number potentially increased or decreased, and then these numeric columns. So hopefully everybody's managed to load that data set into their environment. Again, you could just use code. And hopefully everybody's also loaded up the tidyverse by running library tidyverse. I think I've already done that online. So we've got the capacity AE data, as I've just shown you. If you want to show the data set that you're looking at in a new window, you can click this little button, which I think is the same icon as you get in other places. Where is it? Here, just underneath the data set name. It'll pop it out into a separate window that might be better for you to look at. And you can obviously increase the size of this window if that helps you. So that's the entire data set, all however many rows it has. So, viewing the data frame, we've already done this. Type the name of the data set in the console and press enter, or you can click on the name of it in your environments pane. We've done all this before, so we'll just skim over it. Do we understand the variable names? Right, so ID, site is an ID because there's one for each row, one for each observation. This one that I was querying earlier on, staff increase, is did staff numbers increase between 2017 and 2018? These ones, D cubicle and D weight, is the difference in the average between 2017 and 2018. This is just a quote to say, the simple graph has brought more information to the data analyst's mind than any other device. And this is so true. Most of us work more visually than we do with text. So looking at a table is hard to get the story about what the data are telling you from the table, but plots can really help you do that. We're going to create one to say, is a change in the number of cubicles available in A&E associated with a change in the length of attendance? The statisticians in the room will already have the answer to this as to what they want to see. So what we're going to do is we're going to walk through creating a plot that should help us answer this question. There is an anatomy to how you set up a ggplot2 call. Okay, you start with ggplot brackets, and everything comes after that has a plus. So we're saying, I want to make a ggplot, and I want to use the data that is called capacity AE. Do this. So we'll have capacity, right? So we can do it the way we just showed there, or we can do it as a pipe as we do before. So capacity AE, then ggplot plus, and let's come on and add some things to it. So we need to tell it what data we want to plot, what data set it is, capacity AE. Then we're going to add layers. Now, layers are the things that you want to plot. So at this point, we're going to put points, like a scatter plot, okay? The way we do that is with different geomes. A geome is either a line or a bar or a box plot or a point. And this version we're going to do is a geome point. So we are saying, make a ggplot of data that is the capacity AE and add geome point. And this is really critical. This is aesthetic. This is where we pass to it how we want it to interpret those data. So on the x-axis is the column, the D cubicles, and on the y-axis is the D weight. Let's have a look at doing that. So ggplot, again, this is the other way around that you can do it. You can put the data equals in the call to ggplot. Let's run this and see what happens. So if I make this bigger, you'll see. We have a plots pane down here on the right beside the files pane, and this is where our plots will magically appear. So as you can see, we've asked for points, geome point. So each one of the observations in our data set is now a point on this graph. And the x-axis is the D cubicles. It's automatically chosen the right scale for us. And the D weight is on the y-axis. So that's a nice little plot and a little scatter plot. You can modify this in endless different ways, okay? There are choices about which chart to use, but also the details on the chart. So you can choose what shape the points are. There's loads of different ones. There's squares and there's circles and there's almost endless ones. What shape will represent the data is the geom, as I've said before. Do you want bars? Do you want lines? Do you want points? And what do you want the aesthetic to be? Do you want the actual points to be circles or triangles or whatever? And the aesthetic also is where we give it where the location of where we want to put these things and the color and all the rest of it. So shape, color, size is, if we don't specify these things, it's all the default, which is why our plot looked a little bit boring. Grey background, black little circles. That's the default choices that it makes. We have functions that we can use here, okay? So ggplot2 we've already used, and we've used geomPoint. Aesthetic is also a function, okay? Running a function does something, like a verb. Functions are given either none or some inputs that we call arguments. We've done functions already. You've been using them this entire time. I'm just giving you some of the terminology behind it. The arguments of a function are separated by commas, as we've already seen as well. So the ggplot2 function requires the argument of data. You could omit this and just write capacity AE, because the ggplot2 function is expecting you to give it data, okay? Other arguments, like the axes in A and Y, and X and Y, are in a particular order. So you're specifying within this, the aesthetic function here, the X is d cubicles and Y is d weight. If we omitted the X equals and the Y equals, it will assume that the first thing you give it is the X axis and the second thing you give it is the Y axis. If you wanted that to be the other way around, you would just specify Y equals d weight and X equals d cubicles. But it could be confusing. Let's stick with the standard. What we want to do here then is we want to give ggplot one named argument, the data, and two aesthetic arguments, which is the X and the Y, separated by a comma, as we've already done. And we've already talked about this as well. So these are some of the different geoms, as we said, geometric shapes. There's bars, which funnily enough is called geom bar, geom line, geom box plot, which will automate the creation of box plots, geom histogram, which will automate those kind of binned frequency diagrams. And we can display more than one of these geoms on the single plot just by adding plus and adding another geom to it. So that, in that way we can layer things up. We'll see an example of this in a moment. Don't worry, I'm going quite fast and giving you a lot of information, but we'll play around with this lots if we have time. There's a geom called geom smooth, which I can't remember what the Excel version is, but essentially it's giving us sort of an average of the points. And remember, within the geom plot call, all other bits need to be added with a plus, not a pipe operator. You'll do that a few times by accident. It'll give you an informative message. So let's copy this code and see what happens with it. Make me a geom plot, the data of which is capacity AE. And so if I just ran this bit, right? If I just run this bit, it would give me just a blank area because we haven't told it what we want to plot about capacity AE. We've just said there's a data set and I want you to make a plot of it. Okay. But let's add some geom points to it. Okay. Based on x-axis d cubicles, y-axis d weight. We've seen this before. Now let's do this whole thing. We're wanting to add on a geom smooth, which is a line. And again, the same aesthetics are handed to this where the x and y should be. Let's see what that looks like. Oh, look at this. Lovely. So it's given us a smooth line which goes through the middle of all the points. Okay, it's not a straight line because it's geom smooth, not a geom line. And by default, a geom smooth gives you a confidence interval as well, which is this grey shaded line. So as easy as that, we've got both points and lines on this thing, on this chart. Let me do geom line here just to show you what that would look like. Geom line, so what this is doing is we've not said to do a line as the average, we've just said draw a line between all the points. We've got points here, we've got line here, and this is what you get. Okay. You'll need to play around with ggplot before you get used to this kind of grammar that ggplot2 uses, but it'll become second nature. This is what we've just created in our plotting with the geom smooth and the geom point. We'd probably, if we wanted a linear model, you know how, I'm guessing a lot of you know what a linear model is, I hope. Anyway, we can really, really easily do one of those, plot a linear model by using the geom smooth and just saying as a method, the method equals ln, linear model. Let's do this one, which is the same code again, essentially, but with the linear model through it. So there we are. We've got a confidence interval on here as well now, which you could modify. You can modify the colors of everything. We've got the best fit straight line through this two dimension plot with confidence intervals with this nice little bit of code here that we produced. So what is happening here? Everything is grayed out except for these 2 points. What do we think? What if you were seeing this plot? What would you think these 2 points? What would you think about them? Anyone want to hazard a guess?
The outliers?
Looks like it, doesn't it? These 2 sites have seen staffing increases. We can map these, point color to the staff increase variable. Remember that variable we have that was true or false? Why don't we color the points on our plots based on that, so that the trues will be one color and the falses will be another color? So we can quite easily see whether those 2 points are in a little group of their own. The way we do that is within the geom point, because we're talking about the aesthetics of the points here, in the aesthetics function, the color is, and we hand it the variable in our data, in our capacity AE data, that gives us that true or false. And because it's got 2 different values, true or false, and not lots of different values, it will automatically choose 2 sensible colors for us. Let's do that. And again, put as a linear model over the top. Okay, so this is what it's automatically done here. So can everyone see this all right? Make it even bigger. We've got our dots in the background, which are exactly the same data that we were using before, but this time we've colored them based on that staff increase column. And ours, ggplot2 has sensibly said, okay, we're doing something based on that column. So I'll give you a little key that'll explain these colors. And these 2 outlier dots, and probably this one as well as a few others around here, are the ones that have true in the staff increase column. And because we've chosen different colors, it pulls it out nicely. Obviously, all of these colors are modifiable. We'll show you that in a moment. We could have made those stick out based on having bigger dot sizes or having triangles rather than circles or something. We can change any of those aesthetics, that word is quite important to us, to make the differences in identity from these dots seem quite nice and obvious. Hilary?
Claire, what is that method equals to LM doing? What is it?
Let me show you what that does by doing the opposite. So if I take it out and I run this plot again, so you'll see in our studio, the plot resizes dynamically. So if I pull it open, it'll resize. So what I've done, I've asked it here to do the points colored based on the staff increase as we had before. So the points in the background here are the data points. I've asked it to do a geom smooth, and a geom smooth without the method being LM is a wiggly line that is going through the middle of the points and trying to be the best fit but not straight. Okay, but I'm saying to it, actually no, I do want you to do a linear model. I want a straight line. What is the best fit straight line through these points? So the method equals LM is what that's doing. You see that difference? Within the plots pane, you can
thank you.
You can toggle back and forward through the plots that you've made to make it easy to go back to remember what you just did. Okay. There's also, so I mean, obviously these buttons all kind of make sense. So if you want to export the plot as a PDF or as an image, you can do that based on those. Dead easy. Okay. So the 2 sites have indeed seen an increase in staff levels, which has had an effect on the D weight, even though D cubicles are relatively low. If you want a visual attribute to be applied across the whole plot, then the argument goes outside the aesthetic part. The aesthetic part being the bit after AES, so outside these curly brackets. If you put something inside the AES, it's usually going to give you a legend that explains that thing as well. So let's copy this and show you. So we've said within this one, we want within the aesthetic, the geom point, the colors is going to be red. So let's run this. So we've specified we want all of these to be red. Let's put it outside the aesthetic instead and see what happens. So this has done more what we would expect, right? The one before, this one, where the color equals red was within the aesthetic argument, it's not changed the actual color of the dots, but what it's done is you've said to it, I want to label these red, the word red, okay? And that's why it's given it us here. It's a little bit of a subtle point, but if it's not giving you what you expect, try putting it outside the aesthetic is what I'd say, and see the difference. Because the difference is when we said outside it, I want all the dots, the geom points, to be coloured red. It's gone, all right, no, I get what you mean there. And we don't need a legend anymore, do we? Because they're all the same colour. So we don't need it explained to us by the legend. And you can apply a size globally as well, obviously. So let's do red dots, and size is, I don't know, 3. Run it. Whoa, so 3 is quite big. What if we wanted to do size based on whether you are staff increase or not? Where would I put that? Any idea? Well, because I want to change the aesthetic of some points and not others, we'll put it inside the aesthetic. So I'll pop it here, not with 2 commas. So now all the points should be red because this is outside the aesthetic. But the size, I want it to be based on staff increase. This is a bit ugly having this on a different line. Let's see what this does. Size is not the right thing. So yeah, it's again, I got a warning message there, not an error. It still did something, but it's saying using size for a discrete variable is not advised. That makes a lot of sense, right? Because our staff increase column is just true and false, yeses and nos. And so it's saying, you sure you want to do that? Size isn't giving you much information there. But have a look at our plot. It kind of looks like someone had nosebleed and sneezed on it. Apologies for that. Let's change the color. It's gross, isn't it? Let's change it. You can use words for colors, but they're also, you can use the hex symbols as well. Let's say green. There we go. And so it's taken all the yeses, the trues to be big blobs, and the falses to be little blobs. And that's because we've said do size based on what's in this column. Okay, we can layer up geoms. Okay, those geoms are the types of plots. To avoid duplication, we can pass a common aesthetic. If we always want to color and size and shape things based on the same columns, we can pass that to the original ggplot2 call if it's going to be the same in all of the geoms that we are going to create. So what we're doing with here is we're taking make a plot using the capacity AE data, and for all of everything that comes next, is the aesthetic is that X is D cubicles and Y is D weight. So please do that and add a geom point and a geom smooth. And we've got that plot that we made before, okay? Because what we could do for each of these geoms is change the aesthetics as we did earlier on. But if we want them to be the same for each of them, we can just pop it at the top and then it'll assume that you're carrying those on through the rest of your plot code. Small multiples magic. Another way to visualize the relationship between multiple variables is with facet wrap. Facet wrap's really, really helpful. What this is going to do is make lots of mini plots based on splitting your data by a group. And it's got a little syntax here which uses a tilde and then a space before the column that you're going to split it on. So what I'm asking it to do here is do the capacity AE D cubicles by D weight point scattered plot, but I want to do separate ones for each of the values of staff increase. And remember, staff increase is true or false. So let's have a look at what it does when we add this facet wrap. Remember, we're using plus here because we're in the geom plot. Here, so it's given us 2 plots side by side, which is what we wanted. We still wanted D cubicles as the x-axis on both, and D weight is the y-axis because we passed that up here. We've facet wrapped it. Each of these is a facet based on the values of staff increase. And those values were true and false. And so we get 2 different plots with the relevant data points at each. And you can have as many of those as you like. Obviously, there's an upper limit to how many facets are going to look sensible, squished together, but you can play around with that. It's dead easy to do. If you've got loads of them and you want to lay them out differently, there are arguments you can pass to facet wrap to make that easier. So ncol1 is the number of columns is 1. So if you only want your facets to be, type it, ncol is 1, facets to be in 1 column, not in 2 columns, then you can do this. And what it'll do is it'll dynamically resize them so they fit into your viewer pane nicely, and you have them in 1 column instead of 1 row. How would we find out what the other options are for facet wrap? Or for ggplot, for that matter? Any idea? How do we find help?
F1?
Yeah, we can F1 it. So what can we give it? We can read through this and figure out what we can give it, and we've got examples down here of how we use it. We could go to the ggplot website and we could look at the examples that creates there. But generally speaking, it's giving us arguments here that tells what we can do with it. ggplot is not as useful in this help file as one of these are. So these are all valid arguments to give to it. The ... means you can pass to it other things, and it'll explain that down here as well. Other arguments passed on to the layers parameters argument. So I'm not going to read all this, it doesn't matter. So this is giving us what we can use within the geom point function because we F1'd it to have a look. Right. These are simple unpolished graphics that are coming next, apparently. So how are weight values distributed? So we can run a histogram for distribution, can't we? So here we've got our usual ggplot, which is bringing the capacity AE data, and then we want a histogram of weight. Is this going to show us it so I don't have to actually do it? I'll do it in the code so you can see what's going on. So, quick histogram. Dead simple. Everyone knows a histogram is the count of things when they fall within a certain bin. If we want the bins to be bigger, so these columns to be a bit wider, we can change the bin width argument, which we do with bin width equals, and we can add what we like. So let's see what it does when we have a bin width of 10. Right. Widen those bins. Okay. So you can play around with the bin width of a histogram. Hopefully you'll understand histograms. We'll not stop to explain histograms just now. What about the number of attendances by site? This can be done with a geom call, which is called, and a geom call is another way of saying geom bar plot. Let's see this. It might give us a, we don't use geom call anymore message. No, it's quite happy with that. So we've created a bar plot here that has, for each site along the bottom, remember sites are identified in our data by number, sorry. It's giving us the count of the Y value, which is the attendances in 2018. And we've got this up the Y-axis here. So these are unpolished graphs. You wouldn't use them in this state. It's ugly, isn't it? But we would work with the ggplot to make it look pretty. We can reorder them so that it looks easier it looks like the bars are in a nice order very easily. Again, within our geom column, we're going to reorder. So in our x-axis, reorder the order of the x-axis, please, by attendances 2018. Let's see what this does to it. There we go. It's ordered it by increasing number. This is ugly. We would sort this down here as well to make it more visible. But it's ordered our bars for us in ascending order. If we wanted to order it in descending order, as I've said, because it's numeric, we can just add a negative in there. And it'll do it the other way around. What about the number of attendances by site? Let's do a box plot. I like a box plot. The box plot is as easy as geom box plot. With an aesthetic we're telling it here that the x-axis we want staff increase, y-axis we want D weight. And it produces us a nice little box plot. So staff increase, remember, was true false. So we've got 2 box plots, as it were. We've got false and we've got true. False is first, but not because it's earlier in the alphabet, because behind the scenes, R uses true and false as if they are 1 and 0, and it's ordering them sort of numerically. So we've got two little nice box plots here of the D weight, which you guys will know fine well what a box plot is. It's showing you the distribution of these values along this axis. So it's got the median here, and it's got the range, and it's got the quartiles. We can add plot labels very easily. So on this box plot, let's add, let's say, plus labs labels. We'll have a title, which blah, blah, blah. We'll also have a y-axis name. We'll call it weighting. So now we've got a title on our plot, and we have decided that this is not called D weight, we've called it weighting. So we can make these more human readable by changing the labs, the title. Am I going to, I feel like I'm flicking back and forth a lot, right? I know that you guys are going to go, whoa, too much. Again,
you're going
ggplot
too fast.
Yeah, sorry. We're running up towards 12 o'clock. I'm trying to get through to the point where you guys will be able to just go back to these slides, play with this code, and start working with it yourselves, because I can't, there isn't time to go over it very slowly. Essentially, though, the structure of these calls to ggplot2 are the same. So you're going to make a ggplot with some data, and then you're going to add a geom, a geometric object, to which you're going to pass an aesthetic, which is where the thing needs to be placed on the plot and how you want it to look. And we can layer these things up using plus. And if you remember nothing else, you can remember that. We can save the plots out really, really easily. There's a function called ggsave, which doesn't have to be within the ggplot2 call. It can be by itself as well. And if you do ggsave with the name of the plot as you want it and the extension of the type of plot you want, we'll do as you expect. So let's save a plot, shall we? So I'm just going to do it by itself. ggsave my underscore plot dot JPEG, just for fun. If I click yes now to this, it's going to save a JPEG of the last ggplot I created, the last thing in the plotting pane, and it's going to put it into my working directory. Now, I hope you guys remember what a working directory is, but it's the place on your computer that your R session is assuming you're going to get things from and save things to. If you're not sure where that is, you can write get working directory as get wd, and because I'm working on Posit Cloud here, it's talking about cloud and project. If I were locally, it would be something more like C users, whatever. Let's do it here to show you. Yeah. So this is the place on my computer where it's going to automatically save things to. So we can save this plot very, very easily using ggsave. When you save out plots, you can be really specific about the size and the resolution with heights and widths, and you give it a number for height and width, but you can use this in centimeters, in inches, in pixels if you want. And the way that you do that is by changing the units. Okay. If you're not sure about how you do this, you can do, what about ggsave? I don't understand. Let's open up a help file. This is what ggsave is expecting you to give it. Not all of these things, because a lot of them have defaults. And this is what it will give you. Okay. Again, too much information for us to go through in detail now, but it's just to show that saving plots out of R is dead quick and easy. Okay. That was a super whistle-stop tour for that bit. What I want to do is to stop now. Tell me right now if you want me to show you anything else really quickly from that. And what we're going to do is we're going to take a break before we move on. You will be blindsided by this. It looks like a lot. I've just handed you loads of different things. What I'm trying to do is get you to see that there's a skeleton to how you build up a ggplot. The way you're going to get comfortable with this is by practicing it. So I definitely suggest that you guys take some time with the data that you've got, that we've given you, make some random plots. Play about with things, see if you can change the color, the theme, whatever. Nicola.
2 questions. One, can we specify the size so whatever graphs we create are always the same? And secondly, I think you mentioned a theme. Is there a way to apply a theme?
Yes, and you'll be shocked to learn it's called theme. Okay, you seeing my screen again, yeah? Let's run this plot. So we've got it. So this is the box plot. Let's add a theme. So we go add theme. And this. It's auto-completed and it's telling me these are the things you can put in the theme, okay? There are automatic themes, and there's lots of them in R. I particularly like theme black white. If I press enter there, it's going to apply a bunch of different changes to make it look like a really simple plot. There's also something called theme minimal, which will do, again, a bunch of different changes, takes away the outline. These are a preset group of changes that it's making here, and it'll do lots of different things based on this theme, but you can specify any of them by just using theme and then adding in whatever you want. So let's say I wanted the axis text. Ooh, axis, I can't spell, axis.text. See how it's bringing up lots of options for me? These are all the things I can do. Axis.text is, if we're changing text, you need to wrap it in something called the element text function. Element text, and I want the text to be size is 40 or 30. Run that, and it's increased the size of all of my text. You can add specifics of the theme down to the absolute minutiae based on the things that theme can give you here. So anything to do with the colors, the placement, the text, the scaling, the background, the ticks, anything can be changed with the theme. A lot of places where you're making a lot of plots to go into reports and whatnot, you work together with your colleagues to come up with a theme that you all agree on based on things like text, fonts and whatnot, and colors. And then you all use that same theme. So you don't have to be writing out every time. You just save it as your own package and you just apply theme or workplace, whatever it is. And it automatically, all those changes will happen to your graph. This is what BBC does with their package. Okay, so they've got a package whereby to make sure that there's continuity visually in all of their plots that they produce, they've got a set of theme options that get automatically applied to every plot that they make. The other theme types are should be linked in here. So look at all these things you can change. There's stuff about the axis text, the axis titles, the outline of the whole thing. There's the ticks, major and minor, the lines, the legend, the panel, the strip. I mean, you can change everything. You might not care about any of these, but you can. And it gives you a little explanation of all of them. Theme inheritance. And there's examples of how you apply it as well. Asan.
Do you have to create like a theme for each chart type?
You don't have to mess with the theme at all. If the plot it's giving you is a nice one, you're happy with it. You don't have to change anything at all. And like I say, if you want to specify a theme of your own, what you can do on where's my cursor? On the fly, you could create an object, can you, called maybe my theme or something is. And what you could do in here is you could have all the specifications that you want. You would save this and it would put that my theme into your environment. And then when you get to here, you could just give it my theme. And then it would apply all those changes at once if you want the same theme to happen again. I tend to do a lot of things like increase the font size and mess around a bit with the X and Y titles, just because they're usually in a silly format when they come into it. And try and make sure that my colors are colorblind safe, that kind of thing, for accessibility purposes. You'll have your own way of doing things, but no, you don't have to change the theme at all if you don't want to, if it doesn't work for you, but you can change everything about it. And this is the point of this teaching, is to go, the options are all there. You just need to know that everything is possible with R and go looking for what you need. If you can't find what you need, you can ask for help in the ways that we've talked about earlier on today. Any further questions at this point?
No, I can ask afterwards. I think the other bit was the size, but is that a part of the theme as well, specifying the
size
like
of
it's
what,
putting JPEG, the size of the graph. So if it was to import and put into PowerPoint, it'd always be the same size graph.
Yes. I shut down my slides. I shut down my slides, didn't I? Yeah, at the end of these slides, you've got some saving things. So yeah, the size can be specified within when you're GG saving. So you can GG save on the end of your GG plot call, or like I did, just on a new line, you can just write GG save. And you can specify the units that you want these to be applied in, the height, the width, but there's also other things like pixels and whatnot, and you can use any different type of units so that you can make sure that all your plots are exactly the same size if that's what you want to do. So it's all completely malleable. All the common sense things you might want to do, yes, you can do them. Quram.
Yeah, hi Claire. So just wanted to check. So in the one where we did do changes in staffing. So if you want to save that, you just say gg save in quotes. Do you put in do changes in staffing, that title, or?
Yeah, so what you're giving to GG save assumes that you're talking about the plot that you just made last. Okay, so you don't need to tell it which plot you want to save. It's going to assume that. But what you're giving it is the name and the file extension of the plot you want to save. So it's in quotes because you're passing it a string, and you're saying GG save the last thing I did and call it this. So within those quotation marks where you call it myplot.whatever.jpg, you could also have the entire file path if you want to save it some random place somewhere else on your computer. So that's one way you can save, is using GG save. As I showed though, you can also export your plots from the plots pane in RStudio. You could save it as a PDF, you could save it as an image, and you can save it as different types of image, if this helps you. So these are your options. When you're submitting papers to journals and whatnot, they often have specifications of the type and size and the resolution of plots you need. So you can have a play with this and see if you can get what you need from this. You can specify the height and the width and all these other things. And you can say where you want it to go as well by clicking directory, and then it'll just save it. So if you don't want to do it using GG save, you can just use the export button. You can zoom in on your plots if they're very complicated. It pulls it out into a different thing here, different window. The little broom here sweeps it all away. So you know how we were iterating back through the plots we'd made with these forward and back arrows? If you want to clear all that information, just press the zoom. It'll go, really? Yeah, why not? And so we've now got nothing in our plots pane. We can just remake whatever plots we fancy. Oh, yeah, I haven't actually got a theme in there, so just remake that one. No, my theme is not GG plot is that. See what it's doing here? It's not doing anything because what I'm actually telling it is this. So I'm creating something called my theme, which actually is a GG plot. That's not what I want to do because I've done this here. Look, I've got an open assignment operator. So anything that comes after that, it's assuming it's I'm wanting to make a thing called my theme, and it's whatever comes later. I just want to make a plot. Just want to plot the plot. Thank you. Here it is again. Okay, I think it's time for a break. Let's have a decent break. We've not got huge amounts more to go over, and I want to ideally get some time at the very end of the day for you guys to ask about anything else, and us to get a bit of a chat about what hasn't come up on this course you would have liked and that kind of thing. So let's maybe break till 12:30, if that works for everybody. We'll come back at 12:30 for the final half an hour. If you've got things you really, really want me to mention, to go over, put them in the chat. I'll try and have a look at the chat while we're on break and try and make time to do that. Otherwise, we're really on the home stretch. Nearly there. Done loads today, so well done. Thank you very much. And I'll see you at 12:30, everybody. Bye. Right, welcome back everybody. Hopefully everybody's filtered back in again. So I have you for another half hour today. You'll be thrilled to know. We usually cover 3 more little segments, 3 more little sets of slides to finish off the second day. I'm in 2 minds whether to do those 3 sections today, because half an hour is quite a useful amount of time for us to, if we want to, go back over any of the concepts that we've touched on in the last 2 days, have anything repeated, have anything explained in a bit more detail, or to give you guys time to ask me for any pointers on things that we haven't covered over these last 2 days. So what I might do is I'll show you the first of the 3. I'll tell you what the other 2 are for. And remember, you have all the slides there to be able to go through them at your own time. But after doing the first one, I might open the floor to you guys, and we can talk through anything that you might want to go over again, any concepts that are a bit shaky in your mind, for example. So let's do that. But if you have alternative opinions, those are valid, let me know. Okay, so the 3 things left are using 3 different packages and showing how useful these 3 particular packages can be. The one we're going to work on first is called data pasta. So this comes from an internet term from the dawn of the internet called copy pasta that some of you might have heard of if you're a massive nerd like me. Copy pasta is stuff that got copied and pasted around the internet back in the day before things could go viral. So any little bits of text essentially that were copied and pasted through different chats and all the rest of it were called copy pasta. Copy pasted things, copy pasta. So, and there's a as an aside, there's a version called creepypasta as well, which is like little horror stories that got copied and pasted all over the internet as well. There's a package that R uses, nothing to do with scary stories, called datapasta. And this is a really useful little addition. You'll find yourself sometimes wanting to really quickly take a small table from somewhere else, be it on the internet, be it in Excel, whatever, and you just want to get it into R as an object as quickly as possible. The datapasta package is your friend here. Text data, and it is text data we're talking about here. So it can happen where sometimes someone emails you a little table and you want to just add that into R so you can quickly do something with it in R. And datapasta is a really useful way of doing that. As with all of these different packages, wrapped in curly brackets, that's how we know it's a package, we need to install it, and it creates another add-in, as we've done before. So let's quickly do that. Let's do install.packages datapasta. Off it's gone and it's installed, and we'll load it. We'll take it out of my library by running library datapasta. There. So we've got the datapasta book in our library. We've brought the book out. We've opened it, so we can use what's in it. Once we've done that, our add-ins, again, remember we did this with the styler package. We now have a section called datapasta. Again, on your local version of R, you might need to restart the session. If you can't remember how to do that, pop your hand up and I'll tell you before this can take effect. But online, it does it automatically. So we've got the datapasta section here. We've got lots of different options to use with this one. Here it's showing you the add-ins. And here we've got Clipper add-ins, datapasta add-ins, reprex add-ins. So go straight to having a go at this. I think we'll talk you through it rather than having a go at it. Using a small CSV file for number and percentages of NHS staff by ethnicity, open the CSV, highlight the data and the column names the usual way you would. So when you highlight and you can Control C on something, that's what we want to do here. That puts it onto your clipboard, and the clipboard is what datapasta works with. So, and then in a script or in a Quarto R chunk, in the add-ins, use the paste as tribble. Let me show you what this looks like. So we can use this link. So this is going to give us a little tiny table. I'll put it on my desktop and I'll open it up in Excel. I'll show you this screen when it opens. Bless it. Here's Excel. Whoops. No, it isn't. Here it is. Okay. Here's this little table, right? We don't want to have to type this into R. That would be a pain in the bottom. So let's highlight all these cells. Control C. Out of here again and go into our R. And it's still on the clipboard. So we want to paste it as a tribble. So we just click paste as Tribble. Oh, okay, so it's not going to like this online, interestingly enough. Let's do it in my local version of R instead. So here I'll need to install the package again. I haven't yet. Install packages, data pasta. There's something about when you're on POSIT Cloud, it can't access your computer's clipboard in the same way. I'm sure there's a way around that, but I'm not sure what it is. Library, data, not datasets, data pasta. Okay. So I'll highlight this little table again in Excel, Control C. And then I'll go into my add-ins here. Oh, you see, it's not there. I'm going to have to restart my R. Control Shift F10. Restart my R. Because I've restarted it, I'll have to reload the library. Something I haven't told you yet, although I've told some people when I've been helping them out, is that when you're at the point of adding a function, starting typing by this prompt here, if you want to repeat the thing you last did, press the up key on your. You can scroll back up through the history of things that you typed in by doing that. Okay, so I want to just repeat library data pasta, so I've got it there. Hopefully, here we go there. So now the data pasta is available. Remember, on the clipboard, I've got that little copy Control C thing. I want to paste as Tribble. Let's look at what it's done. So what it's done is from the Tibble package, it's used the Tribble function, and it's taken that little data set and it's made it into these columns that are taken directly from that thing that I copied, the ethnicity percentage column, the estimated number in thousands column. And so it's got all that data there. So if I press enter now, it's just going to repeat that because I didn't ask it to do anything with it, but it's very easily got that data into R. Hopefully, the question that comes immediately next is how do we preserve this thing and make it into an object? There's a hint here, it needs a name and an assignment operator. So if we want to keep this as an object that we can then work with and is a data like this table here, why don't we say new data, we'll call it, and the assignment operator, and then paste as Tribble. Yes, oh, stop it. I didn't have it on the clipboard again, I needed to copy it again. So let's copy it again. And back to R in the add-ins, paste it as a Tribble. And then when we press enter, it's not going to repeat the table in the console because we haven't asked it to. What we've asked it to do is to create a new thing called new data, which is this Tribble. Ignore this warning. It's a warning. We don't need to worry about it. So now the data that we just got from Excel exists as a proper little data set in R, just using this one package. This will work for almost anywhere, not just from taking tables from Excel. You can take them from websites. You can take them off HTML content from websites. You can do lots of different things with it. So it's a really quick, easy little handy thing. So it creates this Tribble. They called it by ethnicity. You can call it whatever you like. Call it something that makes sense, obviously. And that's data pasta in a nutshell. The other two things I was going to show you were the packages janitor and stringer. Janitor is named because it's really good at cleaning things up. And it's useful for, you know, when we loaded in the data sets before that had rows we wanted to skip. It can do that as well. And it can also make all the names, all the column names in your data set into R-friendly names based on that style we were talking about earlier on. And lots and lots of other useful things with janitor. Stringer is for strings. So if you've got a lot of text data, things you might want to do with strings, you know, you'll all know these things, but maybe you want to search for a particular pattern across all strings, or you want to add in suffixes or prefixes or take them away, or all of that kind of text related stuff. Stringer is the package for you. It does loads of different things. We can go through those sections just now in our last 20 minutes, but let's pause instead and let's open the floor to see, has anybody got anything from the last 2 days worth of stuff that we've covered, including the stuff we've just gone over if you want to see it again, that you would like me to run through again or to explain differently or anything like that? Or anything you're worried about when you take your next steps? Hillary?
let me bite the bullet here.
Please do.
Yeah, what am I showing you now?
Showing us a lovely green scatter plot.
Yeah, so I wanted to move beyond this the green scatter plot. Now I can see. Okay, it was before this. So, it didn't. The last coding that you were doing, I think before we took the break, where we were showing the boxes, that failed to run on my side. So maybe if we can go through that again.
Yes, so I can see what you've done, and it's a simple but a common thing that you've done. Okay, in your code here is after the word green, and after you've closed that bracket that's to do with the color element. I can't see it. There's no plus, exactly. So the bit, anything that comes after that is going to be ignored by the geom call. Okay, so try running that again.
No.
So it's telling you what's wrong there. Couldn't find the function gplot. We don't have a thing called gplot. So while you've highlighted, you haven't highlighted the whole thing. So instead of highlighting and pressing run, you can just have your cursor in there somewhere. And then press run, and it will run everything that is connected on that line. Okay, so that's produced a plot for you. It's given you the warning message it gave me, which you can ignore. And it's just saying that you've done something using a numeric scale. Size is a, what's that word? Continuous thing, but you've applied that to a column that's only got trues and falses in. Hasn't stopped you doing it. You've still got big blobs and small blobs, but it's giving you that warning to let you know whether you wanted to do that or not.
Okay.
Okay.
All right. Thank you.
No problem. I popped in the chat, guys, while we were having the break, a couple of links for things that I mentioned earlier on. The first actually is a really lovely website, and I'll share my screen to show you this. It's really, really nice. Is the R Graph Gallery. So the R Graph Gallery has got, well, it does what it says on the tin, really. These are all created with ggplot. Okay, all the types of graph that you might want to make, you can see examples of them and their coding. Oh, bee swarms in here. Okay, so you can get some really nice examples, and if you see the examples, you can also see the code too. It'll talk you through how to create it, how to modify it with different colors and all the rest of it. And the more you look at these, the more you'll start getting accustomed to the grammar of ggplot and different ways of doing things. So have a really nice look around this website. It's got loads and loads of different examples. Every type of plot you could ever make, you can make really nicely in using ggplot. So that's one useful link. The other, I mentioned the BBC has its own package. Okay, they called it bbplot because of the BBC, but it's based on ggplot. So all of the BBC's graphics examples are here, are made using this package that they actually use in their work. You don't need to know about what's in a package necessarily, but you can use this package if you want to make BBC style plots, which is fun. And it's based again on ggplot. That grammar that we learned this morning, or this afternoon even, is all the same. So you'll be able to look at the code that is used and hopefully start to get an idea of what each bit is doing and why it's there. And that link should be in the chat for the bbplot package as well. So you can install that and use it locally. Asan.
Hi there, yeah. I just wanted to check, because I know we talked about reproducibility before as well. If we wanted to create the same chart but several times based on a variable, like, I don't know if it was site or local authority or something like that, is it possible to do that at one point?
Yes. Oh, yes, very. Okay. So what I would usually do in that scenario, this has come up for me a lot, is, so as an example, I had a bit of work I had to do in COVID where I had to map the same type of data for each of the local authorities in the patch that I was working with. And I would need to literally plot the map of the data for each of those different places. So it was a different map with the relevant data on it. And the way I set that up was, first of all, I built one version of it using a ggplot function. And then I wrapped that ggplot into a function that would iterate over each of the local authorities that I was working with. We haven't gone over making your own functions in this introductory course, just because it's a slightly more, it's not difficult, you'll absolutely manage to do it, but it's the next step on, it's an intermediate skill. We do teach function building in the intermediate to R course. And there you'll be able to learn about how to set that up. And yes, of course, you can iterate over things and make as many different plots as you like based on the same structure with the same theming and all the rest of it. And it's a very, very sensible thing to do. You can embed your plots really easily into your quarter documents, and you can create, with one line of code, you can create a version of a really complicated long quarter document for 100 different places or something, whatever it is you're iterating over. And building that up into functions is one of the major powers of coding rather than using point and click kind of IDEs. I mentioned that when we first started, didn't I? That that's the power of this, is to take out the guesswork, take out the copying and pasting, and to make you as lazy as possible, to only have to do something once in your code to give you everything that you need. And so yes, all of that is possible. All of that iteration and functions are possible and are very, very easy too, but we don't have the capacity to do them within this course, I'm afraid. The same place that you got the materials for this course, though, the intermediate R course materials are there, so feel free to have a look at them and have a go based on those if you'd like to. Any other questions? Anything? Can you guys, if there's no questions, can you guys tell me which bit of the last 2 days was the hardest? Which do you struggle with, if anything? Feel free to shout out or write into the chat if you don't want to shout.
Personally, I think at the very beginning, this is just to try to find load where we are.
Yeah, so the sort of starting up the...
Yes.
Yeah, orienting yourself in the program and going, what am I even trying to do here? That takes a little bit of getting used to, doesn't it? But are you feeling much more comfortable with that, Moksha, now?
Yes, I think so. As long as I get familiar with where I get the data, how to do very basic steps, and where to get, there's the rest pretty much like learning other things, isn't it?
Yeah, once you've got that foundation, this is again the point of this course, is to give you that foundation that you feel comfortable making a start. From there, hopefully what you've got out of the last couple of days is you know how to do the basics in RStudio, which is like bring in some data, wrangle that data a bit, maybe make a plot, maybe make a little report, save it somewhere, and then come back to it tomorrow and do a little bit more. You also know where to get help. You know that we have a friendly community that we're always here to help as well. On that juncture, actually, speaking of community, the NHS-R community, which is who, again, we're from and who is providing this course to you, we've got a conference coming up in November. It is free for NHS people, and hopefully you will be able to attend with us. It's hybrid. I'm a million billion miles away from London, but I'll be going down in person, but you don't have to, because we'll be streaming it live as well. And as I say, it's free. I think places are still available. It's on the 13th and 14th of November in London. If you want to come and meet us, I'll be there. Kaylee will be there. The whole team will be there. And it's a really, really good way to make some links with some other people in a similar workplace to you, other ones from all over the place, essentially, because we bring together not just health, but also local authorities and academia and all sorts. So you can meet people at the same place in their development journey as you. So I'd really encourage you to come along to the conference. Kaylee has popped the links into the chat there. And we also have the Slack, which is where we do most of our chatting about these things and where you can ask questions if you're not sure. The Slack link was posted earlier on. Hopefully it's still there in the chat. If not, let me know. We have our website, the NHS-R website, and on there we have lots and lots of different resources. Do have a flick through and use anything that is free. All of it is freely available. You can pick it up, you can use it, you can take bits of it to do with what you wish. Okay. A couple of useful things to point out there. We have the NHS-R Way book, which we'll post a link to as well. That contains the joining instructions and the getting the data for these courses instructions that you were sent at the beginning, but it's got lots of other useful information as well. So I'd encourage you to have a look at the NHS-R Way book. And the other one I wanted to mention is our statement on tools book. So we have a statement on tools book because when you are the only person wanting to up your game by learning coding, instead of using, you know, point and click things from before, like, I don't know, you've got Power BI or whatever, sometimes your IT department can be a little bit worried about the open source nature of the software and giving you the ability and the right to download packages and whatnot. Our statement on tools book is designed to give you a resource that you can just hand to them and say, look, I need it because of this. You don't have to know all the terminology and have to be able to make that argument. But the statement on tools is there to hand to your IT department and go, look, this is safe, effective, and of benefit to everybody. Let me have it. Okay. We're finding that more people are, many more people now are able to use this software locally. And hopefully that is the case with you. If you're facing big barriers again, and you want someone from the community to come and stand up for you, then do contact us in the Slack, and we will help you get started with this. Any questions on any of that? Ram?
Hi, Claire. Yeah, just a question on this POSIT Cloud. So let's say whenever we want to get back into it, does it like create, because you have downloaded it on your machine, you can access it, right?
Yeah. So, sorry, say the question again. I was about to launch into an explanation without really.
So this POSIT Cloud, let's say if I haven't used it for like a couple of weeks or something, and if I want to go back, I just remember the web address, and would the work I've created, it will still be saved and I can access it there, right?
Yes. Yes, it will be.
It's on my local machine because
it's not on your machine, it's on the cloud.
On the
but
cloud,
yes,
yeah,
it'll still be there and you can go back and get it. The warning, the reason we use it in these courses, right, is because, like I was saying, not everybody's got the ability to download and install the things locally. So to get around that and make sure that we're all using the same version of R, etc., POSIT Cloud's a really useful place to go. It's not necessarily safe for you to upload personal data there. So, you know, if you're working on patient records and stuff, I would, as someone mentioned in the chat, I wouldn't recommend you do that on POSIT Cloud because their servers are US based and you won't have permission to do that. But it's a good place to start because it's kind of a safe environment for you to start doing the kinds of things we've been doing. There is a limit to how much you can do on POSIT Cloud with the free account that we've started you off on. So if you're going to go away and consolidate this learning that you've got, and you want to go and do the intermediate TR course next, there are, I think it's monthly limits. I forget what they are though. So you might time out on the amount of free use you can do with POSIT Cloud. Now that you're all proficient with R because you've survived the introduction to R course, your next job is to get it on your machine. I mean, you can download it onto your personal laptop if you want to start playing with it. But as we've said, you'd be better off finding a job in your usual work that you would usually just go, oh, I'll just do that in Excel because I know what I'm doing. Challenge yourself, just a little job. Just do it in R and write the script to do it in R. And the more you can do that and do it locally, the more confident you'll get and you'll build up. Harriet.
Thank you.
I just had a question about Git and GitHub. So presumably, if I want to start doing stuff seriously, I would have to start using Git or GitHub. I don't know if I'll have any like barriers with IT, with like any concerns they might have about that. Which would you recommend as sort of a? Should I go for Git or GitHub?
Great question. Thank you for the question. So Git is the version control software, essentially. Git is how we do version control. You can install Git locally, if you're allowed, you should be allowed, on your machine, and it never needs to touch GitHub. What GitHub is the online website that has servers that you can link your Git to if you want to. So there's a subtlety here that if you want to version control your work, yes, that is a really, really important part of moving forward towards reproducible analytical pipelines. using Git's a great way to do it. There are other ways of version controlling, right? So people sometimes use things like Subversion. There's others, I can't remember. Git's by far the most commonly used version control software. What it does is it keeps a history locally on your computer of every change you've made to the files you've told it to track. That never needs to touch the internet if you don't want to. You can just use Git locally. There and Google it. There are loads and loads of beginner resources for Git. If you want the history of your code and the things you've created to be saved in the cloud, saved on the server, you can use GitHub. That also is great because it means that others can see your code and can collaborate with you. So if you're coding in a group, the best thing to be doing is to host your code on GitHub, and there everybody can use it and see it and interact with it, and then you can code together on that. It's a bit of a jump and a bit of a scary thing for people to start with, right? But you've done a really scary big jump the last 2 days. Git and GitHub are beautiful. They work super well and they're super, super useful. They're not safe. GitHub is not a safe place for storing data in a similar way that the cloud is not a great place to store personal data either. You'll be unsurprised to learn, have an introduction to Git and GitHub course in the same place that you've got the resources for this one. So have a look at those if you want to. But yes, I would absolutely be suggesting that you start thinking about version controlling your code so that you don't end up with loads and loads of different versions of files saved on your computer. And you can always roll back to a previous version whenever you need to.
But I could just start with Git and not have to worry about GitHub, and that would be fine.
Git is keeping it on your local computer, a history of everything you've done, and you just keep it for yourself on your computer. If you ever want to back that up by putting it on the cloud or by sharing it with other people, then GitHub or GitLab is the place to do that. GitHub, generally speaking, is the solution that we use. Is that okay, Harriet? We can help you with that as well. Like, I mean, it is scary, but honestly, once you've got the first few elements of it, you'll be flying. You'll be great. Sharon.
Apologies, I think you have covered this, but I did miss it. Just so we can give our IT department a bit of a nudge, I have already requested R in our studio.
Well done.
What did you say we could give them or point them to? You did mention it. And
I'll grab the links again. We've got a book, another Quarto book. All our books are written with Quarto and freely available online, the code and the output. I'll pop the link in the chat to our Statement on Tools book. If I can do that. Okay, so in the chat is a link to our online book, Statement on Tools. And it'll talk you through the reason why we want to be using certain things, including Git, actually, and GitHub. And it'll give you the evidence you need, ideally, to take that to your IT department and say, this is why I need it. This is why it's legit. I'd be very surprised that if this day and age, if they blocked you from doing this. Well, would I be surprised? I wouldn't be surprised. I would be, you know what I mean? Genuinely, it's very common for people to be using these tools now. You will still get some backwards IT departments who are a little bit risk averse. That's their job. That's fine. It's fine to be risk averse, but we
I think it's just
ways of getting around it.
Yeah, just to give my boss some evidence, really, and that helps support the application. So that was all. Thank you very much.
The evidence you need as well is about moving towards using RAP, using reproducible analytical pipelines, rather than software that you have to pay for, using lots of processes that require your own human memory to do things right. And RAP is the way you get towards doing that. There's loads of information about RAP in the world out there. We got any good links for RAP? Must have loads. Have you heard of the Goldacre report, Sharon?
No.
Okay. The Goldacre report was a report written for government by Ben Goldacre, who is one of our keynote speakers at the conference, just putting that in there to name drop. He wrote a great big thing for the government that is been accepted as the way that the government and the NHS will move towards using reproducible analytical pipelines in everything that we do, because of the massive, massive benefits it gives us in quality, in pricing, in transparency, and all of these things. I'll link to it in here if I can find it. And this is also rather radicalizing. But hopefully, if you give this to your bosses and say, this is why we need to be doing this, it will be some really good evidence for you. So that's the link to the gov.uk Better, Broader, Safer independent report from Ben Goldacre. And if you want to come and hear him speak, guys, you can sign up to our PySoc conference happening in November. Okay, any last questions or clarifications? Okay, cool. Well, it's been a delight to meet you all, ish, that I've met, that I've seen. Thank you so much for coming these last 2 days. You'll receive an email once our recordings are available that will go onto our NHS-R YouTube. The channel for our YouTube, Kaylee will pop it in the chat here as well. It's got loads and loads and loads of videos on there. We've got something like, we've got thousands of subscribers to the YouTube. You'll be able to see previous runnings of this course as well by some of our colleagues. So feel free to watch those. You'll be able to watch this one back, obviously, once the videos are up there. In the email that you'll get to send you to that, once the recordings are ready, there will be a link to a feedback form. Please fill out. I know we all hate feedback forms, but this entire community in this training and all the other training is all run on a volunteer basis. So we receive no money for this. It's all free to you. We are there because we believe in it and we want it to be useful and we want to share what we have learned, and we're massive nerds and we want you to all join us in our nerdery, okay? But we need feedback to evidence that people care about and value what we do. So I really, really, really would be very grateful if you'd I'm at the end of my tether now. If you would fill out the feedback form when it comes through an email. And feel free to sign up to the intermediate R course when it comes round again. So the next one in October is full. I think maybe some of you are going to be there. If so, awesome. I'll see you then. If not, look out for that being run again. And feel free to come back to this one again if you need to. That's absolutely fine. We've had a lot of people repeating. Whatever you need to start your journey towards RAP. Okay. I'll leave you there for today then. Thank you so much. Well done. It's not easy. You've done a really good thing today, and I really hope you've been given the tools to go and have a play and have some fun with it. Okay. Have a really good afternoon, everybody. Lovely to see you. Bye now.
Thank you,
Cheers.
Claire.
Thanks, Claire.
Bye.
Bye. Thank you.
Thanks very much. Bye.